Hello, hello, my dear friends. Anyone is in live? Good evening, good evening. Still, anyone is in live? Still, anyone is in live? Just say me hi if you are in live. Yes, yes. Good evening, everyone. Good evening, good evening. Right. Now, just 2 minutes, we'll start the lecture. Now, today, the JEE and the NTS very important lecture, that is ionic equilibrium. Actually, the ionic equilibrium, the questions we may get very easy and the very tough. There is no any moderate type of the questions will be there. If we clear with the topic, then whatever may be the question they may ask, we can predict the question of the given by the any NTA, right? But for that one, the first of all the concept should be clear for you. Here we are having the what for each and every acid and salt and the buffer having the different pH formula. The terminology, understanding of the terminology is very important. Clear? Now from the starting to the basic to the high level, I will say, and we'll do the questions, and if they have given some different types of the question, which pH formulas we have to use, that all we are going to see in this lecture. Okay, now we'll start the lecture. Good evening everyone. Now if you are not able to understand any concept, just you give me the question mark so that I can stop and I will clear your topic or clear your doubt. And the next thing, when I have given the question, try to do it by your own. Don't do the calculation in the phone. Okay, don't use calculator. Clear? Because in the JEE they will not allow you any calculator. Right? Now we'll start the lecture. Now we'll see. Before going to start, now I hope the video and audio is clear, everyone. Once you say me whether the video and audio is clear so that I can have some idea. Video and audio is clear, right? Video and audio is clear, everyone. The one who is in the live, just say me whether the video and audio is clear. Yes sir, yes. Okay, good. Now before going to start the ionic equilibrium, first of all we have to know the basics of the ionic equilibrium. Now what are the basics of the ionic equilibrium? First of all, what are the acids, what are the bases, and what are the salts? Clear? Now in that, the first we are going to see about the acids. First what we are going to see? We are going to see about the acids and the bases. Here in the acids and the bases, different type of the scientists are given the different types for the acids and the bases. Some scientists they have said the one which donate the H plus is the acid. Some scientists they have said the one which donate the OH minus is a base, and some other scientists they have said some the electron pair acceptor is a acid, electron pair donor is a base. So this type of the misconceptions to clear, first of all we have to study from the basics which are the acids and which are the bases. First type of the acids that we are going to see, that it is the Arrhenius acid base theory. Now what is the Arrhenius acid base theory? According to this theory, the one which gives H plus ion is known as the acid. Clear? Now the one which dissociate in the water to give the OH minus is the base, he has said. Means what he has said, let's suppose this is a one HX. This HX, if we have added this HX in the water, now it is dissociating into the H plus and the X minus. So it is giving the H plus, right? It is giving the H plus. So this is a acid. So what he is saying, this is a acid, right? Done. Now, what is the meaning of the base? Let's suppose MOH. Now, this type of the one species. If I have added this in the water, now it is converting into the M plus and the OH minus. See, this is giving the OH minus aqueous, right? This is giving the OH. So, he has said that this is a base. This is a base. But the one which give the H plus is the acid, one which give the OH minus in the water, it is a base. But limitations of this Arrhenius acid base theory, what we got means, see, by this theory, the one which donate the H plus is the acid, he has said. When it comes to the, good evening everyone, but when it comes to the sodium bicarbonate, you can see this is a sodium bicarbonate. Clear? Now if you cross check for the sodium bicarbonate, this is a sodium bicarbonate. But sodium bicarbonate also, when it has dissociated, it is giving the H plus. It is giving the H plus. But in the nature, sodium bicarbonate is not the acid. Clear? Next one. Next one comes to the NH3. NH3 in the nature, if it is dissociated, it will be converted into the NH2 minus and the H plus, or if it is accepted the one electron, if it is accepted the one electron, it will be converted into the NH4 plus. Right? Now you can see ammonia, even though it does not giving the any OH minus to the solution, but it is in the nature, it will be act as a which one? Base. So why the sodium bicarbonate, even though it is donating the H plus, why it is not the acid? And NH3, why even though it is not donating the OH minus, why it is the base? That Arrhenius acid base theory has not explained. But whatever may be the drawbacks, that theory it did not explain. But this limitation, see, however these limitations can be overcome in the presence of water as a solvent. So we know NH3 is a which one? NH3 is a base. Now when we add this NH3 in the water, now it will be converted into the ammonium hydroxide. This ammonium hydroxide, again it will be converted into the NH4 plus and the OH minus. You see, if this NH3, if we have added in the water, now it is converting into the ammonium hydroxide and it is donating the OH minus. So it is acting as a base. Clear? Now when it comes to the CO2, now you can see this is a CO2. CO2 is the acid, we know, because carbon, it is having the +4 oxidation state. Any species, if it is present in the higher oxidation state, it will act as a which one? Acid, we know. Right? Now CO2, when it has reacted with the water, now what it will be converted? It will be converted into the carbonic acid, H2CO3. Now H2CO3, again it will be donated the which one? 2H plus and CO3 minus 2. Now you can see here the CO2, single CO2 is acid in the nature. What Arrhenius has said, only the species which donate the H plus is the acid acid. But you can see CO2, when it has reacted with the H2O, it is converting into the carbonic acid first. After converting into the carbonic acid, now it is donating the H plus. So it is satisfying the which one? Acidic nature. Clear? Now these are the some examples. Now you can see over there. Done? Clear? Now this is about the Arrhenius acid base theory. Done? Next type of the acid and the bases we are going to see, that is a Bronsted-Lowry acid base theory. Now this is also one very important concept. Now we may get direct questions. From this concept. See, many of the students, they will get confused to identify which is a conjugate acid and which is a conjugate base. This type of the basics, if you remember, easily you can predict the given question or the terminology of the question, it will be understand for you. Now what is the Bronsted-Lowry acid base theory? It has said, according to this theory, the one which donate H plus, it is acid. The one which accept the H plus is the base, he has said. Now with the example we'll see. Let's suppose we are having the H2O, right? H2O plus HCl. Better we'll take the acid first. Now HCl plus H2O, right? Now it is equilibrium with ammonium ion plus Cl minus. Now my dear Sayandeep, actually my explanation part in Hindi is very bad, so that's the reason I'm explaining in English. Okay, I hope you understand. Right, now HCl plus H2O equilibrium with H3O plus and the Cl minus. Now you can see here the one which donate the H plus is the acid, right? See, HCl, it has donated the which one, H plus, to the which one, H2O. H2O, this H plus it has accepted and it has converted into the hydronium ion, and remaining HCl has converted into the Cl minus. HCl has converted into the Cl minus. Now you can see the one which donate the H plus is the acid. Here the HCl has donated the acid. Lecture time I don't know, but max I will finish by 9. Max 9 or 9:30 I will finish. By the max 9 or 9:30 I will finish. Okay. Now this is a HCl, right? HCl is the acid. Clear? HCl is a acid. Why? HCl has donated the one H plus. Now that H plus has accepted by the H2O, right? Now here it is a base. Now this is a base. Now here you have to be very careful. From the acid, after the donating the H plus, leftover anion part. This is a leftover anion part, right? This anion part we call it as a conjugate base. This anion part we call it as a conjugate base, right? Then you can see here. Now this is a base, right? Base after accepting the H plus. Base after accepting the H plus. Now the cationic part will come, right? Now that cationic species we call it as a conjugate acid. This one we call it as a conjugate acid. I hope it is clear. Now H2O, HCl, here it has donated the H plus. After donating the H plus, now the leftover its anion part is a conjugate base. Now base it has accepted the H plus, then after its cationic part we call it as a conjugate acid. Clear? I hope it is clear for you. Now I will write the one species. Then you have to say me which is the acid, which is a conjugate acid, which is a conjugate base, which is the acid and which is a base. Okay. Now here H2O plus NH3, H2O plus NH3, H2O plus NH3 equilibrium with NH4 plus OH minus plus OH minus. Plus OH minus. Hello everyone. Now good evening everyone, good evening. Now you say me here. Now this is a 1, this is a 2, this is a 3 and this is a 4. Among the 1, 2, 3, 4, which is a acid, which is a base, which is a conjugate acid, which is a conjugate base? Now say me 1, 2, 3, 4, which is a acid, which is a base? NH4 is a NH4 is a conjugate acid of 2. Okay. 4 is a conjugate base. 4 is a conjugate base. Now which is acid, which is a base here? Which is a acid and which is a conjugate base? NH3 equal to base, H2O is equal to acid. Right. Good. Now see here the H2O, it has donated its H plus to the ammonia. That H plus it has accepted, it has converted into the NH4 plus. So for this one, this is a base. For the base, now its cationic part will be the conjugate acid. The cationic part will be the conjugate acid. Now for this is the H2O. H2O is the acid. Why? Because it has donated the H plus. So this one will be it's a conjugate base. This one will be the conjugate base. Right? I hope it is clear for you. Now based on this concept, Now we'll do some question, because some species, even though it will act as a amphoteric, clear, even though it will have the amphoteric nature. What is the meaning of the amphoteric nature? No, it can be act as a both oxidizing agent, both it will act as a conjugate acid as well as a conjugate base. Now what are those species? Now we'll see. Here similarly some amphoteric nature. What is the meaning of the amphoteric nature? Amphoteric nature means it can act as a both, or it can react with acid and base. So first of all, when it comes to the best example, I will take it for you. H3PO4 will take, right? H3PO4. Now the H3PO4 can donate how many H plus ions? H3PO4 is a monoprotic, diprotic or triprotic? H3PO4 is a monoprotic, diprotic or triprotic? Now H3PO4 is a triprotic, so it can donate the 3 H plus ions. It can donate the 3 H plus ions. Now here why it can donate the 3 H plus ions? Because oxygen and the hydrogen. Oxygen is a more electronegative. It can pull the hydrogen bond pair of electron towards itself. When it can pull the hydrogen bond pair of electron towards itself, now what it will happen? This bond will become weak. So it can take its bond pair of electron towards itself. So hydrogen can be easily donated. Done? Now here this is a triprotic. Now this H3PO4, when it has donated 1 H plus, now the leftover its conjugate base will be H2PO4, right? Now this is a acid, this is a conjugate base, clear? Now this conjugate base can be act as a both conjugate acid and a conjugate base. How, sir? Now we'll say, if this H2PO4 minus, if it has accepted the H plus accepted, if the H plus accepted, it will be converted into the H3PO4. So this is the acid, right? Now for the same species, if the H plus lost, means that H, if it is lost, then it will be converted into the HPO4 minus 2. Means this is a conjugate base, right? Now this is a conjugate acid. So this species can act as a both conjugate acid as well as a conjugate base. By the loss of 1 H plus, by if it is accepted the H, it will be converted into the conjugate acid. If it is lost the H plus, it will be converted into the conjugate base, right? Now, so I hope it is clear for you. What are the conjugate acids and the conjugate bases of this one? HPO4 minus 2. What are the conjugate acids and what are the conjugate base? HPO4 minus 2. What are the conjugate acid and what are the conjugate base? What are the conjugate acid and what are the conjugate base for the HPO4 minus 2? What are the conjugate acid and what are the conjugate base for the HPO4 minus 2? Are you there? What are the conjugate acid for the Okay, good. Now conjugate base will be the PO4 minus 3, conjugate acid will be the H2PO4, right? H2PO4. Good. Now here, now next one I will write one question. Now you have to see me the answer for this question. Don't be in hurry. Don't be in hurry to give the answer. Read the question carefully. Okay. Now the following species can act as both conjugate acid. For the following species can act both can act both conjugate acid and a conjugate base. Now you have to say me which one will act as a conjugate acid and which one will act as a conjugate base. A. Now A. Now will this act as a conjugate acid and conjugate base? A will act as conjugate acid and conjugate base. Will the A will act as conjugate acid and conjugate base? Yes, good. Now B. H3PO2. Will it act as conjugate acid and conjugate base? Will it act as conjugate acid and conjugate base? This H3PO2, will it act as conjugate acid and conjugate base? H3PO2, will it act as conjugate base and conjugate acid and conjugate? This is very, very important. H3PO2 will not act as conjugate acid and conjugate base because here H3PO2, its n factor is 1. Its n factor is 1. H3PO2, its n factor is 1, so it can donate only one H plus. So it can donate only one H plus and it will be converted into the H2PO2 minus. H2PO2 minus. So this H2PO2 again further it will not lose its hydrogen because it will not lose its hydrogen. So this is not the amphoteric oxide. This is not amphoteric. You have to be very careful with this one. Whenever the H3PO2, they will ask you H3PO2 conjugate base can act as a amphoteric. So you have to say it as no, because here even though you may get it out, sir, here we are having the 2 hydrogen, so it can donate. No, it will not release because these are directly attached to the phosphorus. It will not be released. Only the oxygen attached hydrogen will be released. Okay, this is a very, very important. You have to be very careful. Next one. Now NH4 plus, will it act as a amphoteric? Will it act as a amphoteric? NH4 plus. NH4 plus, will it act as a amphoteric? NH4 plus, will it act as a amphoteric? NH4 plus also it will not act as a amphoteric, right? It will not act as a amphoteric. You have to be very careful. Clear? And the next very key point you have to remember that it is, now the next very key points you have to remember that it is strong acid, conjugate base. Strong acid conjugate base is weak base. Strong acid conjugate base is weak base, right? Next, weak acid conjugate base is strong base, right? Next one. Next, strong base conjugate acid is weak acid, right? Next, weak base conjugate acid is strong acid. Okay, now these are the 4 key points you have to remember. If you remember these key points, whatever may be the acidic strength, whatever may be the basic strength they may ask, easily you can predict the questions. Okay, I hope it is clear. I hope it is clear. Strong acid conjugate base is a weak base. Weak acid conjugate base is a strong base. Strong base conjugate acid is a weak acid. Weak base conjugate acid is a strong acid. Clear? Now, right? Now I will write the one question based on this concept. Now you have to say me the answer. Now he is asking decreasing order of basic strength. Decreasing order of basic strength. Decreasing order of basic strength is asking of the given species CH3O minus, F minus, OH minus and NH2 minus. Now see me the answer. See me the answer for this. See me the answer for this one. What is the answer for this one? Just you have to cross check the conjugate acids. Just add the H plus and you cross check the acids. Acids reverse order will be the basic strength. ADCB. ADCB. Once cross check. One's answer is ADB. ADCB. Good. Answer is a D. This is A, B, C and D. This is a D, C and B. So what I said, just one thing you have to see. What you have to see? Strong acids, just now I cleared it. Strong acid conjugate bases are the weak bases. Then for this one, just you add the H plus. Now this one will be the, for this one, this is a conjugate acid. For this one, this is a conjugate acid. Now for this one, this is a conjugate acid. Now for this one, this is a conjugate acid. Right? Now you can see, now NH3 is a strong base. NH3 is a strong base. And when it comes to the OH, now here the, which one? CH3OH. CH3OH. Now you have to cross check in this manner. Then the answer will get A, D, C and B. Because this is a HF is a strong acid. Strong acids conjugate base is a weak base. Strong acid conjugate base will be the weak base. Next comes to the H2O. H2O and the ethyl alcohol. Now this one will be the strong. Then after that you can see the order. I hope it is clear. I hope it is clear. No, but oh, sorry. NH3 is first, right? Now acid among the NH3 is first. Now the NH2 minus is first. This is not the answer. I was not saying. NH2 is a base, right? NH2 it will become base. NH3 is first. Then after that, among the, which one? CH3OH and the OH. CH3OH is a second. Next will be the OH minus and next will be the F minus. So the answer will be D greater than A greater than C greater than B. So this is the answer. Not A. C, NH3 it is become ammonia, right? Ammonia is a strong base because NH2 minus is the, which one? This is strong base. This is a conjugate base. Clear? Now NH3, this is the order D greater than A greater than C greater than B. Clear? Right. Hello everyone. Hello. I'm fine. I hope the conjugate acid, conjugate base, I hope it's clear. I am fine. Monica, some you are asking, hello sir, how are you? I'm fine, I'm fine. And you? I hope you are fine and doing well. Right? No. Next, the next type of the concept, next we are going to see Lewis acid base, Lewis acid and the Lewis bases. Clear? Now, Lewis acids and the Lewis bases. The next type of the salts we are going to see, that is a Lewis acids and the Lewis base. So in this Lewis acids and the Lewis base, now what he has said, the one which accept the electrons are Lewis acids. Clear? Now the one which donate the electrons are the Lewis bases, he has said. Done? Now in that also we are having the different types of the Lewis acid. How to identify the Lewis acids? Here electron deficient from the octet. I hope you know the octet. Octet means now central atom should have this central atom, something X is a one central atom. This central atom should have the 8 electrons around it. That we call it as a octet. That we call it as a octet, right? Now, if suppose any species, its central atom, it is having the electrons less than 8. Now, that species we call it as a electron deficient from the octet. Electron deficient from the octet, right? Example, BF3. Now, BF3 is a one example because boron trifluoride, how many valence electrons, we are having around the boron? Total 6, right? 1, 2, 3, 4, 5 and 6. Only 6 electrons we are having. Next, BBr3. Clear? Next, AlCl3. Clear? Now, FeCl3. These are the some electron deficient from the octet. It will accept the electron. Now, electron deficient from the octet, see, even though those are neutral, how they are acting as the acids? Now, can anyone see me? See, sir, if any charged species, if it is present, those are acids, sir. Let's suppose H plus it is there. H plus is deficient from the octet. So, deficient from the octet, it requires some electron. But BF3 is a neutral species. But even though it is a neutral species, it is acting as a Lewis acid. Why? Due to the vacant orbitals. BF3, boron, trifluoride, it is deficiency of the 2 electrons. If it is a deficiency of the 2 electrons, now it is having the vacant orbital. In this vacant orbital, it will accept the electrons. When it is accepted the electrons to this vacant orbitals, now it will act as a, which one? It will act as a acids. Right? That's what is saying. The one which accept the electron, that electrons will be accepted by the boron to this vacant orbitals. So it will act as a acids. Clear? Now, next, central atom having the vacant orbital. Central atom having the vacant orbitals means here example PCl5. Next, SnCl2. Clear? Next, SnCl4. Clear? Now these are having the vacant orbitals. See, phosphorus, it is having the, this is a phosphorus pentachloride, right? Now, phosphorus electronic configuration will be 3s2, 3p3. Normally in the ground state. Excited state it will be the 3s1, 3p3 and 3d1. Now we may see, here we are having the vacant d orbital. In this vacant d orbital, now this phosphorus will accept the electron. That's the reason it will be act as a Lewis acid. I hope it is clear. Next, simple cation. Simple cations which are very high reactive. These are also will be act as a, which one? Lewis acid. See, cations. Cations means nothing but electron deficient only. Plus means indicate, you have to be very careful with the sign. Plus means loss of electron, negative means gain of electron. So these are loss of electrons and this will also act as an acid. Next, compounds having the multiple double bonds. Compound having the multiple double bonds means, now let's suppose we'll see. If you take the CO2, now carbon, this is a CO2. Sir, how the CO2 will act as a acid, sir? Why it is acting as an acid means, you can see this is a oxygen. Oxygen is a more electronegative. What it will do? Oxygen, it will pull the bond pair of electron towards itself. So oxygen pulling how many bond pair of electrons of the carbon? 4, right? You can see one bonded pair of electron, oxygen is pulling. Next, this bonded pair of electron, oxygen is pulling. This bonded pair, it is pulling. This bonded pair, it is pulling. So carbon is getting the deficiency of 4 electron. So carbon is getting the deficiency of the 4 electron, means it can accept the 4 electron. So it is accepting the electrons, right? That's the reason it will act as an acid. It is accepting as a electron, so it will act as an acid. Now when it comes to the SOCl, SO2, in this SO2 also same. Here oxygen is pulling the 4 electrons of the sulfur, so it will accept the electrons to this one. Done? Clear? I hope it is clear. Now next one. The next concept we are having, Lewis bases. So what are the Lewis bases? What are the Lewis bases means, now the one which, what are the Lewis bases? Electron pair donor. Electron pair donors are called as a, good evening everyone, good evening Alidasan, good evening. Now electron pair donors are called as a Lewis bases. Clear? Now you can see the simple anions. Simple anions is nothing but Cl minus and the OH minus. Cl minus and the OH minus. This negative charge paired electron can be donated to the, which one? Any required species. So it can donate the electrons, right? It can donate the electron. Next, molecule containing one or more lone pair of electron. Now you can see H2O contain how many lone pair of electron? 2 lone pair of electron. So H2O can donate the electron pair. Now when it comes to the ammonia, it can contain 1 lone pair of electron. Next, if you take the alcohol contain, oxygen contain 2 lone pair of electron. This lone pair of electron will be donated to the any required species. Next, if you take the R2S, S contain 2 lone pair of electron. It can donate to the any required species. Clear? Now, next, multiply bonded compounds which donate the lone pair of electrons. So, multiply bonded compounds which donate the lone pair of electrons is nothing but carbon monoxide. If you see the carbon monoxide. Clear? Now, this is, we can call it as a carbonyl. Right? Next, NO. Here, these are multiply bonded electrons. Now, these are multiply bonded electrons. It can donate the electrons. Right? Now, next, factors affecting the Lewis acidic strength. First is a nuclear charge. What is the meaning of the nuclear charge? Now you say me among the Sn plus 4 and Sn plus 2, which is having higher nuclear charge. Can anyone say me? Among the Sn plus 4 and the Sn plus 2, which is having the higher nuclear charge. Next, among the Fe plus 3 and among the Fe plus 2, which is having the higher nuclear charge. Among the Sn plus 4, Sn plus 2, among the Fe plus 3 and the Fe plus 2, which is having the higher nuclear charge. Which is having the higher nuclear charge. Sn plus 4, Sn plus 2, Fe plus 3, Fe plus 2. No. Sn plus 4 is having the higher Lewis acidic strength and Fe plus 3 is having the higher. See Nana, why you are getting confusion? See here, Sn plus 4 and Sn plus 2, right? Sn plus 2. Sn plus 4 is having the nuclear charge plus 4. Now, Sn plus 2 is having the nuclear charge plus 2. See, Sn plus 2, 4 is having the higher nuclear charge, means higher nuclear charge. Sir, more electron deficient, same nuclear charge. This is more nuclear charge, right? More nuclear charge, higher the nuclear charge, higher it will accept electrons fastly, right? It will accept the electrons fastly than the Sn plus 2. So it will accept the electrons very fastly, right? It is having the higher nuclear charge. Even though it is having the same vacant orbitals, but Sn plus 4 is having the, which one? Higher nuclear charge. Due to the higher nuclear charge, what it will happen? It will accept the electrons very fastly. What is the meaning of the Lewis acid? The one which accept the electron pair. Means among those two, Sn plus 4 is accepting the electron very fastly. So among the Fe Fe plus 3 and the Fe plus 2 also, Fe plus 3 will accept the electrons very fastly than the Fe plus 2. I hope it is clear. I hope it is clear. See, nuclear charge, higher the nuclear charge, higher is a Lewis acidic strength. Higher is a Lewis acidic strength. Next, more the number of electronegative atoms are attached to the central atom, more will be the acidic strength. So this is also one very key point you have to remember. So how to identify among the SO3 and among the SO2, which is a more acidic strength? Which is a more acidic? Among the SO3 and among the SO2, which is more acidic? SO3. Why? Because SO3 you may get a oxidation number is plus 6. Now here the oxidation number is which one? Plus 4. You can see on the basis of the oxidation number also. Higher the oxidation number of the atom, higher will be the acidic strength. Why the higher the oxidation number on the atom will be the higher acidic strength? So here sulfur has lost the 6 electrons. Now here the sulfur has lost the 4 electrons. Sulfur has lost the 6 electron means it will accept the electrons very fastly than the sulfur, right? Clear? Now the SO3 will be the higher acidic strength than this one. And the one very key point you have to remember that it is all the Bronsted bases are Lewis bases, but all the Bronsted acids are not the Lewis acids. All the Bronsted acids are not the Lewis acids. So examples you can see, all Bronsted bases are Lewis bases. Lewis bases. See HCl. HCl Bronsted base is a Cl minus. Now the Cl minus is also will act as a Lewis base. But here this is the NH3. NH3, this will be the NH4 plus is a conjugate acid. Clear? Or Bronsted acid. This one we can say it as a conjugate acid or the Bronsted acid. But this is NH4 plus will not act as a Lewis acid. Will not act as a Lewis acid. Why? This NH4 plus octet has been completed. You can see this NH4 plus octet has been completed. If this NH4 octet has been completed means why it will accept the electron? It will not accept the electron, right? Then why it will act as a Lewis acid? So all the Bronsted bases are the Lewis bases, but Bronsted acid or conjugate acids, all the conjugate acids are not the Lewis acids. I hope it is clear, this point. This point is clear, right? Done? Is it clear? I hope this point is clear. So you have to be very careful with this point also. Right. Next, the next we are going to see about the salts. Yes. The next we are going to see about the salts. After the salts, we are going to start the electrolytes. After the electrolytes, we'll do the pH for the each and acid, and we'll do the questions also. Next, very fastly, I will finish this salts type. Now, what is the meaning of the salts? Salts is nothing but a substance which ionize in water to produce other than H plus and the OH minus ions are called as the salts, right? Now, the types of the salts, first we are having the neutral salts. Neutral salts. In these neutral salts, what we are having? NaCl. Clear? K2SO4. Now KNO3. Neutral salts means this resultant pH will be the 7. Clear? Next one, the basic salts we are having. Basic salts. So what are the basic salts we are having? Sodium carbonate. Now sodium acetate. Clear? Now next one, mixed salt we are having. Mixed salt. What are the mixed salt we are having? Now CaO, Cl2, calcium oxychloride. This one we call it as a bleaching powder. Clear? Now these are the some salts we are having. Now based on the salts we are going to see the concepts also. The next very important concept, ionic equilibrium, that we are going to study. So what the ionic equilibrium that we are going to study? Before going to study the ionic equilibrium, now what is the meaning of ionic equilibrium? Ionic equilibrium means Now, what is the meaning of the chemical equilibrium? In this chemical equilibrium, we have studied now equilibrium, that it is existing between the gaseous species in the closed container. But what is the ionic equilibrium? Here the equilibrium exists between ionization process. In the ionization process, equilibrium will be established. Now the equilibrium will be exist in open and closed container. In both the open and the closed container, both the cases, ionic equilibrium will be established, right? Now how the ionic equilibrium is establishing between the ions and its undissociated compound? Now we'll see. Before that, what we have to know? We have to know about the electrolyte. So before going to start the ionic equilibrium, now this concept is very clear. If this concept, if it is clear for you, now the entire ionic equilibrium part, it will become easy for you, right? Now the compounds which give ions either in the molten state or solution state is called as an electrolyte. In the solid state, it is a bad conductor of electricity. Now there are two types of the electrolyte. One is the strong electrolyte. What is the meaning of the strong electrolyte? Means the electrolyte mostly completely converted into the ions in the polar medium. Example, NaCl, strong acids, strong base, salts of strong acid and the strong base. Sir, how come, sir? How to identify this whether the given compound is a strong electrolyte, weak electrolyte? Sir, why it will be completely converted into its respective ions, or completely converted or completely dissociate? Means, best example I will take you. Let's suppose let's take NaCl. We'll take better example. Now this NaCl has formed from the which one? HCl plus NaOH. This two combines to give the NaCl plus H2O. Now this NaCl will act as a strong electrolyte. Sir, how this NaCl will act as a strong electrolyte? Means, let's suppose this is a NaCl. This NaCl, if you add in the water, right? Now H2O, we know H2O is a polar solvent. Why I wrote these two negative charges? Because oxygen, it is having the two lone pair of electron. Electron is negative charge. Now hydrogen, it is having the partial positive charges, right? Now when the NaCl, when I have added in the water, it will be dissociate as a Na plus. Now this Na plus as surrounded with the H2O molecule. This Na plus as surrounded with the H2O molecule. When this Na plus as surrounding, or this Na plus positive charge and this Cl minus, when the H2O is trying to surround this Na plus, what it will happen? Hydration energy will be released. The hydration energy utilized by the which one? NaCl, and the bond, whatever may be the strength between the Na and Cl it is having, it will be broken out and it will be completely converted into its respective ions, that it is a Na plus and the Cl minus. I hope it is clear. That's the reason whatever may be the strong acids, strong bases and salts of strong acid versus strong base. And very key point you have to remember, sir, what are the strong acids and what are the strong bases? Can you give me the example? Okay, I will give you the examples. Now you see here, let's suppose HCl. It will be completely converted into its respective ions. Means, what is the meaning of the completely converted into respective ions? Means, I will explain. Wait. Now next is a KOH. Okay. Next is a HNO3. Done. Next is a H2SO4. Right. Next is a NaOH. Next is a calcium hydroxide. So these are the strong electrolytes completely converted into ions. Next one, very important point about the salts. Salts, first one NaCl. This is a NaCl. NaCl, it has came from the strong acid plus strong base. This is a strong electrolyte. Okay, but some other species also there which will behave as a strong electrolyte. Which are those? Means only one key point you have to remember. Key point. For the salts, either cationic part or anionic part, either cationic part or anionic part. If it has came from strong acid or a strong base, that salt is strong electrolyte. This is a key point you have to remember. If you remember this basics, the ionic equilibrium application will be easy for you, right? What is the key point you have to remember? For the salts, either cationic part or anionic part, if it has came from the strong acid or strong base, that salt is strong electrolyte. Now we'll see the one example. CH3COOH. Now this is a weak acid, right? And one is a strong base. If these two weak acid and the strong base, if these two reacts to give the salt CH3COONA, right, plus H2O. Now this is sodium acetate salt is a strong electrolyte. Sir, how the sodium acetate salt is a strong electrolyte, sir? Means now how it will be dissociate? It will be dissociated as the CH3COO minus plus Na plus. Now you see, this is a cationic part, right? Now this cationic part has came from where? Strong base. Now this, what I said, for the salts, either cationic part or anionic part, if it has came from the strong acid or the strong base, that salt is strong electrolyte. Now you can see this cationic part has came from the strong base, so this is a strong electrolyte. This is a strong electrolyte, blindly believe. Next one, ammonium hydroxide. This is a ammonium hydroxide is a weak base plus HCl. HCl is a strong acid, we know. Now this will be converted into the ammonium chloride, right? Now this, how the ammonium chloride will be dissociate? NH4 plus and a Cl minus. Clear? Now this Cl minus has came from where? Strong acid. Now what I said, either cation or anion. Now this is which part? Anionic part, right? This is a anionic part. Now this is a cationic part. Now see, either cationic part or anionic part, if it has came from the strong acid or the strong base, those salts are the strong electrolytes and it will be completely converted into its respective ions. I hope it is clear. I hope it is clear for everyone. Done? Now next comes to the weak electrolytes. Now what is the meaning of the weak electrolytes? Means these weak electrolytes are not completely converted into ions, right? Now its degree of dissociation is very less. Sir, what is the meaning of the degree of dissociation? What is the meaning of the degree of dissociation? Degree of dissociation will be represented by the alpha. So what is the alpha? Alpha represents, alpha is equal to number of ions dissociated by total number of ions before dissociation. Total number of ions before dissociation. This is called as a degree of dissociation alpha. So which are the weak electrolytes? Which will act as a weak electrolytes means, example, weak bases, weak acids and salts of weak acid plus weak base. This will act as a weak electrolytes. What is the meaning of the weak electrolytes? Weak electrolytes are not completely converted into its ions. It will not completely converted into its ions, right? Now example for the weak electrolyte salt, now we'll see. Best example, if you take now CH3COOH, right? Now this is a weak acid. This weak acid plus ammonium hydroxide. Ammonium hydroxide is a weak base, right? Now this two combines to give the CH3COONH4 plus H2O, right? Now this one is a salt of which one? How it will be dissociate? CH3COO minus and it will be the NH4 plus. But what I said, either cationic part or anionic part, but this anionic part has came from weak acid, and its cationic part has came from the weak base, but then only it will be act as a strong electrolyte. But this 2 has came from the weak, right? So why it will be act as a strong electrolyte? It will not act as a strong electrolyte. So for the basically to make you to understand what is the meaning of the weak electrolyte, generally here weak electrolyte, what we can say, let's take the one acid. This is a weak acid, right? Weak acid, generally, let's suppose I have taken the 100 molar of its concentration, right? Now 100 molar of its concentration when I have taken, now this ion when I have added in the water, this acetic acid of 100 molar when I have added in the water, what it will happen? It will be converted into the, first it will be converted into CH3 COO minus plus H plus. It will be converted into CH3 COO minus and the H plus. So initially 100 molar, right? From this 100 molar, only 0.01 molar and only 0.01 molar of the acetate ion and the H plus will be formed in the water. After some time what it will happen? Again this 0.01 molar and 0.01 molar of the acetate ion and the H plus, again it will combines to give the acetic acid. Again this 0.01 molar will be formed and 0.01 molar again it will combines to the acetic acid. See here acetic acid is dissociating into the acetate ion and the H plus. Again this acetate ion and the H plus, again it is combining to give the acetic acid. So this process, forward reaction and the backward reaction, both it is happening, and you can see, and the equilibrium is established between undissociated acid and the dissociated ions, undissociated acid and the dissociated ion. And this type of, you can see now the equilibrium has been established between which one? With the ions, right? Here the acetate ion and the one is H plus ion. Clear? Between the ions the equilibrium has been established, right? That's the reason we call this as a ionic equilibrium. This one we call it as a ionic equilibrium. So generally if you want to represent the ionization constant, how the equilibrium constant Kc Kp we have expressed, the same one now the ionization constant if I want to express. So how to express the ionization constant for this one? Let's suppose instead of, just to make you to understand, I have taken the 100 molar, but generally how to represent this one, some C concentration of the acetic acid I have taken. Now this is 0 0 at initially time t is equal to 0 when I have not added in the water. Now you can see from the C some C minus alpha has been dissociated. You can see as per the equilibrium, for 1 molar of the acetic acid, 1 molar of the acetate ion is forming. Now from the C minus alpha, 1 is giving 1, then C alpha will give you C alpha, right? So here it will get the C alpha, 1 is giving 1 H plus, means here also you will get the C alpha. Done? Now we know how to write the K equilibrium. How to write the K equilibrium? Products by reactants or reactant by product? You know, products by reactants is a equilibrium, right? So this is a ions. So we are going to say this as a ionization constant. Ionization constant is equal to, these are aqueous species, right? Aqueous species, we can say it as a concentration of acetate ion by concentration of H plus ion, concentration of acetate ion, and the concentration of the acetate ion by concentration of acetic acid, Clear? Now here for this one, if we want to express, what if we want to express? Now if you want to express the Ki and if you want to see the ionization constant, how much ionization constant it is having. Now for the acetic acid we are having the C alpha, now H plus ion we are having the C alpha, now acetic acid we are having the C into 1 minus alpha. Now you can see here, this is, we can write like this, right? For the acetate ion C alpha, H plus ion C alpha, for the acetic acid C into C alpha. So we can write this as a C into 1 minus alpha. We can write it 1 minus alpha. Now here this 1 minus alpha will play very crucial role. Now you can see here the C cancel, then C cancel means C alpha square by 1 minus alpha. Now this 1 minus alpha will play very crucial role. So how to see this alpha? Now what is the meaning of the alpha? The number of ions dissociated by total number of ions before. Here what I am saying, initially how much molar of the acetic acid I have taken? 100 molar, right? 100 molar of the acetic acid I have taken. From this 100 molar, how much acetate ion has been converted? 0.01, 0.01. Means in comparison with the 100, 0.01 molar is very negligible, right? Means here the completely 99.99 molar of the acetic acid is in the form of acetic acid only. It has not converted into its respective ions. If it is converted into the respective ions only, we can say it as a dissociation. But very less extent it has been dissociated, right? Very less extent it has been dissociated means in comparison with the dissociated ions concentration and undissociated acids concentration, if you compare, what it will happen? That ions concentration can be neglected. If we have neglected this one, so alpha value, if it is well, up to which dissociation, how much dissociation we can neglect the alpha? Means we can neglect the alpha up to 5%. Up to 5% we can neglect the alpha. Means here the alpha value, if it is very less, then 1 minus alpha, if it is less means it will be equal to the 1, right? Then this entire term will become 1. So this Ki will become C alpha square. Ki will become C alpha square. So when to neglect the alpha and when to not neglect the alpha? When to neglect the alpha and when we have to not neglect the alpha, that they will give you in the question. Depending upon that question only, you have to whether to neglect the alpha or whether we should not neglect the alpha, that it will play very crucial role. So for all the cases, you should not neglect the alpha value here. If it's a dissociation constant, if it is less than 5% only, then only what you have to neglect the alpha. Sir, when we have to neglect the alpha, when we should not neglect the alpha? If alpha, if it is not neglected, then how to solve it? Now we'll see based on the one question. Okay, now based on the one question, now we'll see when to neglect the alpha, when to not neglect the alpha, right? Now what I said, if the alpha dissociation is less than 5% only, we can neglect this alpha. Then Ki will become C alpha square. Then alpha will become under root Ki by C. Now we'll see one question based on that, whether to alpha can be neglected or not. Now calculate the concentration of each species. Calculate the concentration of each species for 0.1 molar solution of weak electrolyte AB. So for that one, the ionization constant 1 he has given on the basis of 10 to the power minus 5. One ionization constant he has given on the basis of 10 to the power minus 2. Now when first we have to cross check the given alpha for this ionization constant, whether the alpha value we are getting it less than 5% or not. Now we have to see. Now first of all, by neglecting the 1 minus alpha, what we got? Alpha is equal to under root Ki by C. Then when we can neglect this 1 minus alpha, if alpha value if we got less than 5% only, this formula will be valid. According to the given Ki. Now whether this formula is getting valid or not, now we'll see. Now alpha 1 will be equal to under root Ki by C, right? Under root Ki is how much? 10 to the power minus 5. Now concentration C is how much? 10 to the power minus 1. Now this one will become 10 to the power minus 4 and you will get it as a 0.01. So here alpha value for the given Ki, we got it as a 0.01, which is less than 0.05. So this alpha value can, for this given Ki, we can neglect the alpha. For the given Ki, what we can do? We can neglect the alpha, right? Now, but next one we can see. For the next case, if you see whether we can neglect the alpha or not. For the next case, whether we can neglect the alpha or not, now we'll see. The next case, if you see the alpha is equal to under root 10 to the power minus 2 by 10 to the power minus 1, 10 to the power minus 2 and the 10 to the power minus 1, and if you solve this one, you will get approx 0.136 something you will get. Means here 0.136 alpha is greater than 0.05 percentage, right? 0.05 or 5 percentage. Means here this formula is not valid. Means alpha under root ki by c formula is not valid. So to get the answer, what we have to do? We have to solve the quadratic equation. By the quadratic equation, we'll get the answer. Sir, how to solve the quadratic equation, sir? Now we'll see. Now, how to solve the quadratic equation? Now the quadratic equation, we know alpha ionization is equal to minus b plus or minus under root b square minus 4ac by 2a is the formula. So for the given ionization constant, how to solve the which one? Alpha value. We know Ki, how much they have? Ki is equal to C alpha square by 1 minus alpha is the formula we know. The Ki, how much they have given? Ki in the question 10 to the power minus 2 they have given. Now concentration, how much they have given? 10 to the power minus 1 they have given. That is the alpha square by 1 minus alpha. Now if you send this 1 minus alpha to the left hand side, how much it will become? It will become 10 to the power minus 2 minus 10 to the power minus 2 alpha and minus c alpha square is equal to 0. Directly I have wrote in the form of the expression, right? Now by this, if you make it into the positive, what you can get? C alpha square plus 10 to the power minus 2 alpha minus 10 to the power minus 2 is equal to 0. It is from this, if you solve or whatever the values it is there, if you put it in this quadratic equation, you will get the alpha value. Right? In this manner you have to solve the alpha. I hope it is clear. When to neglect the alpha value and when to not to neglect the alpha value. Clear? First you have to cross check. After cross checking whether the alpha value, if it is getting less than 5 percentage, then directly you can use the which one? Directly we can use this formula. If suppose if the alpha value, if we are not getting the less than 5 percentage, then we have to use this quadratic equation, and by this quadratic equation we have to solve the alpha. I hope it is clear. I hope it is clear for everyone. Or still you are having any confusion? I hope it is clear. I hope it is clear for everyone. Or still you are having any confusion? Yes, clear, sir. Done. Now, right. Now, if it is a clear, now we'll move to the next one. Ionization constant of weak acid and the weak base. So, what are the ionization constant of the weak acid and the weak bases? First one, if you take the one weak acid HA, it will be dissociated as a HA plus and A minus, HA plus and the A minus. Now, if I write the ionization constant for the acid ionization constant Ka is equal to direct, this is a C alpha, this is C into 1 minus alpha. Directly I am writing. This will become C square alpha square by C into 1 minus alpha. Now C cancel. Ka is equal to C alpha square 1 minus alpha. This is, we call it as a ionization constant of acid. This we call it as a ionization constant of acid. Done. Now if you go it for the base, base what we can write? We can take the any normal base. Ammonium hydroxide is a normal weak base. It will be converted to the NH4 plus and the OH minus. Now if you write the C0 0, C into 1 minus alpha, C alpha, Now base, right, we are representing it as a Kb. For this one also C alpha square 1 minus alpha. This is for the Kb. Clear? Now this one we call it as a ionization constant for the base. This one we call it as a ionization constant for the base. I hope it is clear. Done. Next one, the next concept that we are going to see, the Ostwald's dilution law. Now what is the meaning of the Ostwald dilution law? According to this law, weak electrolyte upon dilution, it will behave as a strong electrolyte. So what is the meaning of the strong electrolyte? How the weak electrolyte behaving as a strong electrolyte? Now we'll see. Here, first one thing you have to remember, what you have to remember means, for any strong electrolyte, its alpha value will be tends to 1. Completely it will be dissociate, right? So its alpha value will be tends to 1. Done. For the weak electrolyte, alpha value will be between 0, alpha, and it will be in between the 1. In between 1. Clear? Now, for the weak electrolyte, alpha value will be between 0, alpha, and it will be the 1. For the strong electrolyte, it will be tends to the 1. So, upon dilution, how the weak electrolyte is behaving as a strong electrolyte? So that it was explained by the Ostwald dilution law. What is the meaning of the dilution? Means, if you take the one weak acid, let's suppose this is a weak acid, acetic acid only better will take to make you to understand. This is a acetic acid, is a weak acid, we know. This acetic acid, weak acid, when I have added in the water, this is a H2O. This acetic acid is a 1 liter of water. Now this acetic acid, how much 100 molar concentration it is having. When I have added this acetic acid 100 molar concentration in the 1 liter of water, then it has been dissociated into its respective ions 0.01 molar. Okay, 0.01 molar, and the H plus also 0.01 molar. Here this acetate ion plus H plus, it has been converted into 0.01, 0.01. Clear? 100. When in the 1 liter of aqueous solution, then next again 1 liter of 1 H2O I will add. 1 liter of 1 H2O I will add. Means that it will become dilute, right? Dilute means what it will happen? Volume is increasing. Volume is increasing means concentration will be decreased. So next, after adding the 1 liter of water, then what happened? From this 99.9, from 99.9 again some 0.01 will be dissociate. Here again 0.01 will be formed, 0.01 will be formed. Here before 1 liter of dilution. Next 1 liter I have added. Next again extra 1 liter I have added. Then again after extra 1 liter I have added, total it will be the 98. From this 99.98 again 0.01 will be dissociated. Again the 0.01 will be formed, 0.01 will be formed. See, in this manner, upon dilution, strong electrolytes will be converting into the respective ions. Means, see, the concentrations of the acetic acid is decreasing upon adding the dilution. So, when this complete 100 molar of the acetate ion, when it is converted into the 100 and the 100, and it should become 0. So, to happen like this, how much dilution I have to do? How much dilution I have to do? That it was explained. That it was explained by the Ostwald dilution law. By doing the infinite dilution, weak electrolyte will be completely converted into the strong electrolyte. Weak electrolyte will be completely converted into the strong electrolyte. He has explained. I hope it is clear. Now, how, sir? Now we'll see based on this one. Based on the one general example. With the general example, I will take one general example and I will explain. Now, here one AB type aqueous is a one weak electrolyte. It will be converted into A plus aqueous and B minus aqueous. Right? Done? Now, if I write the ionization constant for this one, C0, 0, C into 1 minus alpha, C alpha, C alpha, right? Now, its ionization constant Ka will be equal to C alpha square by 1 minus alpha. Now, if this is a weak electrolyte, right, the 1 minus alpha will be tends to 1. Then, its Ki will be equal to C alpha square. C alpha square. Then here we know, right, alpha is equal to under root Ki by C. Then it is, this formula is justifying alpha is inversely proportional to the C, right? Alpha is inversely proportional to the C. Then here upon decreasing the concentration, upon dilution, what it will happen? Now upon dilution, concentration of the electrolyte decreases. Concentration of the electrolyte decreases means up to how much dilution I have to do? How much dilution I have to do? To do how much dilution? I have to do the infinite dilution. At infinite dilution, now it's whatever may be the concentration we have taken, it will become 0. Means this concentration should become 0. When this concentration will become 0? When I do the dilution infinite. See here, initially I have taken the 100 molar. Now this 100 molar will be completely converted into its respective ions, right? When it will be completely converted into respective ions, and it will become 0. When I do the dissociation, when I do infinite dilution, alpha infinite is equal to 1 minus 0, right? This, if I make the 0, its concentration to behave as a strong electrolyte. To behave as a strong electrolyte means its complete concentration should be converted into the products. Then even its complete concentration, when it has converted into the products, its concentration will become 0. 1 by 0 will become, alpha will become infinite. Means at infinite dilution, weak electrolyte will be completely converted into its respective ions, and it will behave as a strong electrolyte. Weak electrolyte will be act as a strong electrolyte when at a infinite dilution. I hope it is clear. I hope it is clear. I hope it is clear for everyone. Or still you are having any confusion? I hope it is clear. Or still you are having any confusion? Clear, done. Now still the chapter has not at all started. The basics, these basics will play to understand the terminology of the question. So that's the reason I am explaining basics very clearly. If these basics are clear for you, terminology of understanding the question will be easy for you. Okay. The next one. Next very important concept that we are going to see, that is a common ion effect. That it is common ion effect. Right? What is the meaning of the common ion effect? Right, clear. Right. Now, what is the meaning of the common ion effect? Means when the strong electrolyte is added to the weak electrolyte, in which it is having the common ion, is called as a common ion effect. Clear? Common ion effect. Here, just in the basic manner, in the general understanding, I will explain. Then after that, I will write what are the points it is having. Let's suppose this is a weak electrolyte. This is a weak electrolyte. Weak electrolyte, best example we know that it is a weak acids are the weak electrolytes. So this is a acetate ion, CH3COO minus plus H plus ion. Okay. This is a acetic acid, this is a acetate ion, and this is a H plus. This is a weak electrolyte. Okay, this is a weak electrolyte, CH3COOH, and it is having the 100 molar. From this 100 molar, some 0.01 molar has been dissociated, 0.01 has formed, 0.01 has been formed. Now the leftover will be the 99.99 molar will be there at the product side. Right? Now for this solution, I am adding one strong electrolyte which is having one common ion to this weak acid. So for that one, I am adding the one strong electrolyte, that is a CH3COO. This is a strong electrolyte, right? What initially startingly I said, either cationic part or anionic part. If it has came from the strong acid or the strong base, it will be act as a strong electrolyte. Strong electrolyte means completely converted into its ions. Means completely converted into ions means for this sodium acetate salt, when I have added in this, which one? weak electrolyte. Now sodium acetate. Sodium acetate also I have taken the 100 molar concentration. So initially it is 100 molar before, when I was not adding to the acetic acid solution. When I have added into the acetic acid solution, again it will be converted into the acetate ion and it will be converted into the Na plus. Okay, done. Clear? Right. This is a strong electrolyte, right? When it has converted into its respective ions, now sodium acetate salt will not be in the form of sodium acetate. It will be in the form of its respective ions. Here the 100 molar and here it will be the 100. Right? Now you see here, this in the same solution, we are having the how many ions total? 4 ions we are having. In the solution we are having the 4 types of the ions. What are the 4 types of the ions we are having? One is acetate ion of salt. This is salt acetate ion 1 and it is having the 100 molar concentration. Next one, we are having this one acetate ion concentration of the acid. It is having 0.01, right? And we are having the undissociated acetic acid, which is 99.99 molar. Now you can see in the same solution, same ions should not have the different concentration. This is very, very important. In the same solution, same ions should not have the different concentration. It should have the same concentrations only. So then this acetate ion concentration will become 100 and this acetate ion concentration will become 0.01. Total, this is a common ion, right? This is a common ion. For this acetic acid, this sodium acetate, when I have added, this acetate ion is a common to it. So that's the reason we are saying it as a common ion. Now in the same solution, common ion concentration should not be different. Common ions concentration should be same. This is the one key point you have to remember. In the same solution, two different or the same or common ions, concentration should not be different, it should be same. So now in the entire solution, it has become 0. We are having the 99.9 molar of acetic acid and 100.001 molar of acetate ion concentration we are having in the solution. Now equilibrium will shift towards which direction? Backward direction or forward direction? Now you see me. Now in which direction equilibrium will be moved? Now the acetic acid undissociated form, it is in the form of 99.59 molar. Now the acetate ion concentration is 0.01 initially and 100 molar it has came from the strong electrolyte. Now this is there and it is a 0.01. Now equilibrium will shift to which direction? Equilibrium will shift to backward direction, right? Because product side concentration is more. If the product side concentration is more, to balance that concentration, reaction should shift backward direction. So reaction will move which direction? Reaction will move backward direction, right? If the reaction 1 minute. Now if the reaction is moving the backward direction, right? Now means what we can say, and the next thing, one key point you have to remember. Here this is a acid acetate ion concentration. Now this is a salt acetate ion concentration. In comparison with the acid acetate ion concentration and salt acetate ion concentration, whose acetate ion concentration will be more? Ante what I am going to explain means, here this is a acid acetate ion. Now this is a salt acetate ion. In comparison with the salt acetate ion concentration, acid acetate ion concentration we can neglect, right? We can neglect or not? Because here salt acetate ion concentration is 100, acid acetate ion concentration is 0.01. So in comparison with the salt acetate ion concentration, acid acetate ion concentration can be neglected. So in the common ion effect, the key points you have to remember. What are the key points you have to remember in the common ion means? First one. Now when the strong electrolyte is added to the weak electrolyte, now in comparison with the acid's common ion or acid's common ion concentration can be neglected. So what we have to write? Now when strong electrolyte is added to weak electrolyte, now weak electrolyte common ion can be neglected, right? Weak electrolytes common ion will be neglected, and equilibrium will shift backward direction, I hope it is clear up to now. Done. Up to the common ion it is clear. About the salts, about the bases, about the ionization, common ions, everything it is clear. Everything it is clear up to now. Yes. Now if it is the clear, now we are going to start the real chapter of the ionic equilibrium. Now the very interesting chapter of the equilibrium will be starts, and the sums also will be very interesting. The terminology is also very interesting, and everything it will be very interesting. From now complete basics has been clear. Now there is no any now again and again this basics again and again I will not explain, means in the upcoming the derivation parts. Now again this common ion concept will come, again this ionization constant will come, again the acid base, this is acid, this is a base, and this will be react with water, strong electrolyte, weak electrolyte, again I will not explain. Okay, these are the basics, almost I made it clearly. Now the actual chapter it is going to start. Now the actual chapter it is going to start with the first ionic product of the water. First is ionic product of the water. Now what is the meaning of the ionic product of water? So ionic product of the water. Now in the ionic product of the water, the first we are going to see, I have taken the 1 liter of pure water. 1 liter of pure water. Now in this 1 liter of the pure water, H2O is a weak electrolyte. So sir, how the H2O is a weak electrolyte? Now for the weak electrolyte only the equilibrium will be established. So how the H2O is a weak electrolyte I will explain. Okay, this is 1 liter of pure water. Now when it has converted into its respective ions H plus aqueous and OH minus aqueous, if I write the ionization constant for this one, how to write? Concentration of H plus and a concentration of OH minus and a concentration of H2O. Now we know activity coefficient for the pure solids and the pure liquids will be taken as 1. So this one will be the constant. This constant if you send it to the left hand side, now Ki into concentration of H2O will be equal to concentration of H plus and a concentration of OH minus, right? One constant into constant, that we call it as a new constant. That new constant we call it as a Kw. This Kw we call it as a ionic product of water. This one we call it as a ionic product of water. Kw will be equal to H plus ion concentration and the OH minus ion concentration. Kw is equal to H plus ion concentration into OH minus ion concentration. I hope it is clear. Now here one very key point you have to remember, that it is many of the students they are getting confusion and they are making a mistake. They are repeatedly, even though they know the concept, still they are doing the silly mistake here. What is the silly mistake you guys are doing in the exams is, experimentally the Kw value has given. Experimentally experimentally Kw value is equal to 10 to the power minus 14 molar square they have given. That too at 25 degrees Celsius only they have given. That too at 25 degrees Celsius only they have given. Means this Kw value will be applicable only at 25 degrees or 298 Kelvin. When it will be applicable? It will be applicable only at 25 degrees Celsius or 298 Kelvin. Means Kw will be, next one, Kw will depends on temperature. Kw will be depends on temperature, and this is a two key points you have to remember. This is a two key points you have to remember. Most of the cases they will ask you the pH based on the increasing temperature. So if they ask on the basis of 25 degrees and the 298 Kelvin, the resultant pH for the H plus ion concentration and the OH minus ion concentration 10 to the power minus 7, 10 to the power minus 7 we can take. But when they increased the temperature, then the H plus ion concentration and the OH minus ion concentration also will be changed. So how it will be changed now we'll see. Now Kw value is 10 to the power minus 7 at 25 degrees Celsius. So Kw is equal to H plus ion concentration and OH minus ion concentration. So at 25 degrees Celsius, what is the H plus ion concentration and what is the OH minus ion concentration we are going to see. Let H plus ion concentration equal to OH minus ion concentration equal to X we are taking. We don't know, right? Just let we are assuming some X. Right? Now the Kw value will be 10 to the power minus 14 molar square. Now H plus ion concentration, if it is X, means OH minus ion concentration is also X. Clear? Now that it will be the X square. Now that's X, if you send it to the left hand side, X is equal to 10 to the power minus 7 molar. 10 to the power minus 7 molar. X value, if you got the 10 to the power minus 7 molar, means at 25 degrees Celsius, H plus ion concentration is 10 to the power minus 7 molar. This H plus ion concentration is 10 to the power minus 7 molar. Both the cases at a ionic product of water at 25 degrees Celsius, if they ask how much is the H plus ion concentration, how much is the H plus ion concentration, if they ask, you have to say it as a 10 to the power minus 7, 10 to the power minus 7. Next thing, next very key point they will ask you. 1 liter of water, 1 liter of water, 1 liter of H2O. 1 liter of H2O contains 10 to the power minus 7 moles, 10 to the power minus 7 moles of H plus ions. Can I say it or not? 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 1 liter of H2O contain 10 to the power minus 7 moles of H plus ions. Can I say it or not? In this manner, can I say it or not? Sir, here you have said this as a molarity, molarity 10 to the power minus 7 mole or molar, and you are saying the 1 liter of H2O contain 10 to the power minus 7 moles of H plus ions. Sir, how, sir? We know, right? Molarity is equal to number of moles by volume in liter. Right? Now, 1 liter of H2O contain 10 to the power minus 7 molar of H plus ions. 1 liter, right? How much I have taken? 1 liter. If the volume is 1, then molarity will be equal to number of moles. Then 1 liter of H2O also contain the 10 to the power minus 7 moles of H plus ion per liter, right? So per liter will be same, right? Clear? Now molarity will be equal to normal number of moles by volume. So volume is 1 liter. So molarity will be equal to N. So 10 to the power minus 7 molar. So 1 liter of H2O contain 10 to the power minus 7 molars of H plus ions. 10 to the power minus 7 molar of H plus ions. Then now 1 liter of H2O contain how many moles of H2O? 1 liter of H2O contain how many moles of H2O? This is a very, very important point. 1 liter of H2O contain how many moles of H2O? 1 liter of H2O contain how many moles of H2O? 55.5 moles of H2O will be there. Now I think so there is something competition is going on between the Pranit and Suvana. Clear? Now we'll see who will win. Now the 1 liter of H2O contain how many moles of H2O? Means 1 liter, right? Density of H2O. Density of H2O is 1 gram per ml. 1 gram per ml. So 1 liter contain 1000 ml, right? 1000 ml means now 1000 ml. Now 1000 ml of water contain 1000 grams of H2O. 1000 grams of H2O. 1000 grams of H2O means molarity will be equal to number of moles 1000 by 18. Now 1000 by 1000, that it will be cancelled and that it will give you the 55.5 moles. 55.5 moles. This is a very key point you have to remember. 1 liter of H2O contain 55.5 moles of H2O. Then 55.5 moles of H2O contain how many moles of H plus ions? Now 55.5 moles of H2O contain 55.5 moles of H2O contain how many moles of H plus ions? 10 to the power minus 7 moles of H plus ion. 10 to the power minus 7 moles of H plus ion. Okay. Then 1 mole of H plus ion, then 1 mole of H2O if it is dissociated. 1 mole of H2O if it is dissociated, how many moles of H plus ions will be given? Okay. Now if the 55.5 moles of H2O contains 10 to the power minus 7 moles of H plus, means if suppose 1 mole of H2O if it is dissociated means, then how much it will give? 10 to the power minus 7 by 1000 by 18. Because 55.5 moles we can write it as a 1000 by 18. Then degree of dissociation alpha. This degree of dissociation alpha will be equal to 1.8 into 10 to the power minus 9 at 25 degrees Celsius. Now you can see in the 25 degrees Celsius 1 liter of pure water contain 55.5 moles. In that 55.5 moles 10 to the power minus 7 moles of H plus ions are there, right? Then in that, instead of 55.5 mole, if I take a 1 mole of water, then in that 1 mole of water will be dissociated into how many ions? So 1 mole of H2O will give you 1.8 into 10 to the power minus 9 moles of the H plus ion. Means how much? See, you can see compared to the 10 to the power minus 7, 10 to the power minus 9 is small, right? So 1 liter of H2O contain 1.8 into 10 to the power minus 9 moles of H plus ion, which it is having the less dissociation constant. So that's the reason H2O is a weak electrolyte. H2O is a weak electrolyte. I hope it is clear. Based on this one also they are asking the questions. Based on this concepts also they are asking the question. Now this is about the ionic product of the water. This is about which one? Ionic product of the water. Next one we are going to see the pH. Next one we are going to see pH. Now what is the meaning of the pH? pH is nothing but power of hydrogen. So power of hydrogen. Now more detailedly I am not going to this power of hydrogen, that activity, based on that activity the power of hydrogen will be dependent, because that it is not that much important for us. So directly I am going to take, because if I say pH is equal to minus log of concentration of H plus ion, if I say, we know concentration is nothing but molarity. Molarity is equal to mole per liter. So the pH unit should be also be the mole per liter, but there is no any such type of the unit for the which one? There is no such type of the unit for the which one? pH. No unit will be there. No unit for pH. That no unit will, why the units are not there for the pH? Because now it's activity for the dilute solutions. Let's suppose now here why the pH is not having any units means, first of all pH will be expressed in the form of activity of H plus ion concentration. Activity of H plus ion concentration. So activity will be expressed in the form of gamma C by C naught. C by C naught. Now this is a standard C naught concentration will be the 1 molar. Now this C is the H plus ion concentration of the acid which we are going to see. This is H plus ion concentration of the acid, right? Now here this activity will be expressed for the two solutions. One is a dilute solution, one is a concentrated solution. Concentrated solution we are not going to deal. Now dilute solution, C will be less than 1. C will be less than 1. Clear? Now the activity of H plus will be C. Then here for the which one? For the dilute solution, gamma value will be 1. If the gamma value will be 1, then what it will happen? C by C naught. C by C naught. Here the gamma value, whatever the gamma value it is having for the dilute solution, it will be 1. Right? If it is a 1, now the activity for this concentration, 1 minute, better I will make it short. You can see now if it is 1, gamma value if it is 1, now the activity of H plus ion will be equal to C by C naught. C by C naught, activity of H plus will be equal to C by 1, because standard C naught concentration is 1. Standard C naught concentration is 1. Then that C is the H plus ion concentration of the any acid. H plus ion concentration of the any acid, that in the place of C we are going to see it as a H plus ion. H plus ion. Now you can see here the concentration, here the concentration, because here you may get a doubt, sir, why the pH is not having the unit. Now here the concentration is mole per liter. Now below is also having the concentration C naught, right? That's concentration C naught is also mole per liter. Mole per liter will be get cancelled. That's the reason pH is not having any units, no unit for the pH, right? And the pH is only applicable for the dilute solutions and the dilute bases. This is also one important point you have to remember. pH is applicable for dilute solutions and dilute bases. Dilute solutions and the dilute bases, right? Now based on this one, now the pH formula we got that it is pH is equal to minus log of H plus ion concentration of its normality. H plus ion concentration of its normality, and in our chemistry we are going to take it as a base 10 only. pH will be taken as base 10 only. Then here this H plus ion concentration will be taken as a 10 to the power minus pH, and we can write this pH is equal to minus log base 10 1 by H plus ion concentration of its normality. And this normality formulas you have to remember. Normality is equal to molarity into n factor. Okay, normality is equal to molarity into volume into n factor. This is also one key point you have to remember. Clear? Now these are the pH formula. Now the direct calculation of the pH, key points for the pH. What are the key points that we are going to remember for the pH? Now the key points for the pH is, and the direct calculation of the pH. So instead of remembering the log values, now if you remember this key points of pH. What are the key points of the pH? If H plus ion concentration is 10 to the power minus x, then the pH will be, first one, if the H plus ion concentration of its normality, the H plus ion concentration of its normality is 10 to the power minus x, then the pH will be equal to x. Sir, how sir? Now let's suppose HCl aqueous of 10 to the power minus 2 molar, calculate its pH. Calculates its pH. Now you see pH is equal to minus log of H plus ion concentration, right? Minus this HCl will give you the 1 H plus, and its concentration is 10 to the power minus 2 molar. So minus log of 10 to the power minus 2. 10 to the power minus 2. Now it is in the form of log a power m. Now that it is a m log a, right? M log a. Then it is in the form of the m log a. Then here the minus 2 and here it is a minus. pH will be equal to 2 into log 10. Log 10 will be the 1. So pH will be equal to 2. That only I said you, right? Here what is the minus x? That it will become the x. Here the minus x is 2. Then the pH will become 2. pH will become 2. So whatever may be this x value it is there, whatever may be this x value it is there, that will be the pH. When? If the H plus ion concentration is 10 to the power minus x. Next one. The next key point. If the H plus ion concentration, if the H plus ion concentration is in the form of x into 10 to the power minus y, x into 10 to the power minus y, then the pH will be, y minus log x. Then the pH will be y minus log x. Sir, how sir y minus log x? Now we'll see. Here same HCl aqueous solution concentration, it is having 0.02. Then calculate its pH. Then calculate pH. Right? Now this HCl, from this HCl we get the H plus ion concentration. It is in the form of 2 into 10 to the power minus 2 molar. Now it is in the form of yes, it is in the form of x into 10 to the power minus y, right? X into 10 to the power minus y. If it is x into 10 to the power minus y, then the pH will be equal to minus log 2 into 10 to the power minus 2. Okay. Then it is in the form of the log a into 2 kada, 2 into 10 to the power minus 2 into 10 to the power minus 2. Then it will become 2 minus log 2. 2 minus log 2. Clear? It is in the form of y minus log x, right? Now it is a y, it is in the form of 2. So it will become 2 log 2. 2 minus log 2, log 2 value will be 0.3. It will become 1.7. 1.7. Directly this type of, if you remember this one, directly you can calculate. Next one, statement based questions they may ask. Based on this statement based questions also, so most of the students they are getting, even though they know the concept also, in the statement based question they are doing the mistake. But why, I don't know. Here see, now normally at 25 degrees Celsius, now Kw will be equal to the 10 to the power minus 14 molar square, right? Then based on this one, the pH scale we have seen will be up to 0 to 14. Now at which one? Neutral solution. When the solution has become neutral, when the H plus ion concentration will be equal to the OH minus ion concentration. If the H plus ion concentration and the OH minus ion concentration, if it is equal, then we can say the solution is neutral. Then at 25 degrees Celsius, H plus ion concentration is 10 to the power minus 7 molar, 10 to the power minus 7 molar. Then the resultant pH, if you calculate for the both, then we are getting 7. So we can say that it is a 7 is a neutral pH. 7 is a neutral pH. Then here you can see, when we can say the irrespective of the, don't see in the form of negative. Don't see in the form of the negative. Okay. Sir, if the H plus ion concentration, if it is increases, H plus ion concentration will be increases means it will be the 10 to the power minus 6, 10 to the power minus 5, in that manner. Okay, in that manner 10 to the power H plus ion concentration increases. So here the many of the students are getting confusion. This is a neutral solution at 25 degrees Celsius. 7 is a neutral pH, it is a 14 and it is a 0. Then if the H plus ion concentration, my question is, if H plus ion concentration of its normality increases 10x times, 10 to the power x times, 10 to the power x times, then pH will decrease how many times? Then pH will be increases or decreases or remain same? pH will be increases how many times, pH will be decreases how many times, or pH will be remain same times. pH will be decreases x times. pH will be decreases x times. This is a very important point. pH decreases x times. Sir, how the pH will be decreases x times, sir? Now let's suppose for the given solution, this is a neutral solution. This H plus ion concentration is let's suppose this is a acidic solution. This is a basic solution. This is acidic. For the one solution, H plus ion concentration is 10 to the power how much? 4 or x times. Here if you do neutral, 10 to the power minus 7, 10 to the power minus 7, this is a neutral solution and its pH will be the 7. For this one, if I have added the water, H plus ion concentration, if I have increased it to the 10x time, 10 to the power x times, means 10 to the power x time means 1000 power or 10 to the power 3 times. If I have increased 10 to the power 3 times of the H plus ion concentration, if I have increased 10 to the power minus 7 and the 10 to the power minus 10 to the power 3 will become 10 to the power minus 4. Then pH will become 4, right? From 7 to 4 it has reached, means 3 times it has decreased, right? Means 1000 times if you increase the pH, same, means 10 to the power 3 times if you increase the H plus ion concentration, the same 3 times the pH will be decreased. See, from the 7 it has reached to the 4. I hope it is clear. 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 Now the next one, same key point you have to remember. If the H plus ion concentration of its normality, if it is decreases 10 to the power x times, then pH increases x times. Then pH increases x times. Then pH increases x times, right? Now this pH scale will be up to 14 at a 25 degrees Celsius only. Until up to 25 degrees Celsius only this will be applicable, right? I hope it is clear for everyone. Now we'll see here, if the temperature increases, what happened to the pH? What happened to the pH? What happened to the pH scale? Now whether it will be shrink or whether it will be expand, whether it will be remain same or not, now we'll see. Here now this H2O plus H2O, when it is reacting, it will be converted into the hydronium ion plus OH minus at a 25 degrees Celsius. At 25 degrees Celsius it is giving 10 to the power minus 7 molar. It is giving the 10 to the power minus 7 molar H plus ion concentration and the OH minus ion concentration, and the pH will be 7. pH will be 7. Now you have to say me pH of pure water is always 7. It is true or false? pH of pure water is always 7. It is true or false? pH of pure water is always 7. It is true or false? It is false. pH of pure water is not always 7. It is false, because pH will depend on temperature. pH will be depend upon the temperature. If the temperature changes, pH of the pure water will also change. pH of the pure water will also change. Sir, how it will change, sir? Now we'll see. If temperature remains constant, If temperature remains constant means H plus ion concentration of its normality will be equal to OH minus ion concentration of its normality will be equal to Kw. We know Kw is a temperature dependent. Kw is a temperature dependent. So now if I have increased power of hydrogen, now here now if we increase the temperature, what it will happen? Now the experimentally Kw of the pure water at 25 degrees is 10 to the power minus 14 molar square at 25 degree. Then if we increase the temperature to the, let's suppose 60 degrees Celsius, then what happened? Kw of the pure water also will be increased to the 10 to the power minus 2, 10 to the power minus 12 molar. Means here as the temperature increases means Kw also increased. If the Kw is increased, then Kw will be equal to H plus ion concentration of its normality and OH minus ion of its normality. Then Kw of the pure water will be 10 to the power minus 12 molar. Then x and x if you take, then 10 to the power minus 7 means x and x. This will become x square, right? X square will give you 10 to the power minus 6 molar. Means at a 60 degrees Celsius, now 1 liter of pure water concentration, is 10 to the power minus 6, 10 to the power minus 6. Then if I calculate the pH for this one, pH how much I got? 6, right? pH how much I got? 6. Means as the temperature increases, H plus ion concentration increases or decreases? H plus ion concentration increases or decreases? H plus ion concentration increases. H plus ion concentration increases means pH decreases. I hope it is clear. Means you can see as the temperature is increasing, what it is happening? H plus ion concentration is increasing. As the H plus ion concentration is increasing, now what happened to the pH scale? pH scale is shrinking or expanding. It is getting expanding or it is getting shrink. It get expanded or it is getting shrink. pH scale what happened? It is getting expanded, it is getting shrink. Now if it is getting shrink means what happened to the resultant pH? Resultant pH is decreasing. I hope it is clear. Shrinking means resultant pH is decreasing. I hope it is clear. Now one thing, just remember this one. If now you have to say me, if H plus ion concentration increases, then we know, right? We are having the pH plus POH will be equal to pKw. Or else if you want to cross check for the pH, after the pH we are having the POH, right? What is the POH formula? POH is equal to minus log of OH minus ion concentration of its normality. This is the POH formula. Now the pH formula, pH is equal to minus log of H plus ion concentration of its normality, right? Now here I will write one points, you have to say me the answer. Okay. Now if H plus ion concentration of its normality, decreases, then OH minus ion concentration of its normality increases. Then what happened to the pH and POH? Now sim, if H plus ion concentration decreases, then OH minus ion concentration increases. Then what happened to the pH and POH? Then what happened to the pH and POH? pH increase. Okay. POH Good. If the H plus ion concentration is decreasing, then pH will be increases. H plus ion concentration is decreasing means if suppose if it is in the 10 to the power minus 1, if it is decreased to the 10 to the power minus 9 means then H plus ion concentration is 10 to the power 9. Now the pH will be 9. If OH minus ion concentration is increasing, OH minus ion concentration is increasing, before it is at 10 to the power minus 7. Let's suppose after increasing it is reached to the 10 to the power minus 5. Means compared to the 10 to the power minus 1, 10 to the power minus 5 is high. Then POH value will become minus log of OH minus ion concentration. 10 to the power minus 5 will become 5. Here it will become 9. So POH will be decrease and the pH will be increase. I hope it is clear. This is clear. Done. Next, if the now I will write one point you have to see. If temperature is variable, means temperature is not fixed. If temperature is variable, okay. If temperature is increasing, then what happens to the pH and the pOH? Now same, what happens to the pH and the pOH? What happens to the pH and the pOH? If the temperature is increasing, if the T is variable, temperature is increasing, what happens to the pH and the pOH? What happens to the pH and the pOH? What happens to the pH and the pOH? Why both will decrease? Why both will decrease? What happened to the pH? Good. Now, right now here we know Kw will be the H plus ion concentration and the OH minus ion concentration, right? This is a X and this is a X. This will be equal to the X square will be equal to Kw. X will be equal to root Kw, right? Now as the temperature increases means Kw is also increasing. Kw increases means H plus ion concentration and the OH minus ion concentration both are decreasing. Ionic product of the water. No. Temperature increases means Kw value will be increases. Root Kw value will be increases. Root Kw value increases. As the temperature increases, root Kw value increases. Root Kw value increases means this X square value also will be, what it will happen? Will also increase. X square, this H plus ion concentration and the OH minus ion concentration also 10 to the power minus 6. 10 to the power minus 6 concentration both also will increase. Clear? This Kw increases means concentration of H plus and the OH minus 6 increases. Increases means scale will shrink. Scale will shrink means pH before it is a 7. It will become 6. It will become 6. Kw is directly proportional to the temperature. Kw is directly proportional to the temperature. That you have to remember. That starting only I said. Means here if the temperature increases, what happened to the pH and the pOH? Both will decrease. Both will decrease. X square. So both will decrease. pH and the pOH will be decreased. Right? This is the one key point you have to remember. In the statement based questions, they will ask you. See, this type of the questions only they will ask you. If this type of the concepts if you clear, now you will not get any confusion in the statement based questions or whatever maybe they may ask. I hope it is clear. Done. Now already it is 2 hours. Let's take the 15 minutes break. Okay. We'll take the 15 minutes break and we'll start the class exactly at 6:50. 15 minutes break we'll take and 6:50 p.m. we'll start the class. Okay. We'll start the class. Now, up to now the pH done. Now we are going to start the pH formulas. Now we'll take the 15 minutes break. Hello, hello, my dear friends. Are you there? If anyone is in the live, just say me hi. If anyone is in the live, just say me hi. Hi, hi, hi. Yes, 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 yes. Now, okay, fine. Now we'll start the class. Now, here we know if in the solution H plus ion concentration and the OH minus ion concentration, if it is there, that solution we can say it as a neutral. If the H plus ion concentration, if it is greater than OH minus ion concentration, then we can say that the resultant solution is a acidic. Now, if the OH H plus ion concentration, if it is less than OH minus ion concentration, then the resultant solution we say it as a basic. Clear? Now this we have to remember. H plus ion concentration and the OH minus ion concentration. If the H plus ion concentration, the resultant solution it is a acidic, and the resultant solution it is a basic. Clear? Now whether it is a basic or whether it is a acidic, based on this one we get to know. Clear? Now next thing we are going to see here. Now the important formulas of the pH scale. Now okay, I will give you one question. Now you have to say me the answer. The question is, now the Kw of the water is 10 to the power minus 30. Kw of the water is minus 30. Then H plus ion concentrate, then the pH found that it is a 6.5. The pH found that it is a 6.5. Clear? The pH found that it is a 6.5. Then the resultant solutions, the pH found to the pH found to be 6.5. Then the solution, will be, A acidic, B basic, neutral, A acidic, B basic, C neutral, D none of the above. Now say me the answer. What is the answer for this one? Now if the Kw is 10 to the power minus 13 and the pH is 6.5, now the resultant solution will be the neutral. Clear? Why the resultant solution is neutral? Can anyone? Can anyone say me why the resultant solution is neutral? Because here the Kw they found that it is 10 to the power minus 13. 10 to the power minus 13 means now the pH scale will be up to 0 to 13. 0 to 13 means the neutral solution will be having the pH 6.5. The neutral solution pH it is having the 6.5. Clear? I hope it is clear. 6.5, the resultant solution will be the neutral. Not acidic, not basic. You may get a confuse. pH scale will be for the 0 to 13. Right? Now, good. Right. Next. The next one we are having the important formulas of the These are the some important formulas we are having. That important formulas we have to remember. What is that important formulas we are having? That pH is equal to minus log of H plus ion concentration of its normality. Then next one we are having the POH. POH is equal to minus log of OH minus ion concentration of its normality. Then next pKw. pKw is equal to minus log Kw. Next one we are having the pKa. pKa is equal to minus log Ka. Next one pKb. pKb is equal to minus log Kb. Clear? And the next one important formulas we are having, that it is a pKa plus pKb is equal to pKw, that it will be equal to 14 at 25 degrees Celsius. Sir, how sir this one? Now I will derive and I will explain. Next one, the another formula we are having the pH plus POH is equal to pKw. Now pKw will be equal to 14 at 25 degrees Celsius. Sir, how this formulas it has came? Now that I will explain. Here just H plus ion concentration and the OH minus ion concentration will be equal to Kw, right? Now take negative log on both sides. Take negative log on both sides. Negative log on both sides if you take, then minus log of H plus ion concentration into minus log of OH minus ion concentration is equal to minus log Kw, right? Now log A into B. Log A into B will be this one. If you take the better, I will write it is in this manner. Now concentration of OH minus. Now you say me log A into B. Log A into B will be equal to log A plus log B. So we can write like this, right? Log H plus ion concentration plus minus of log OH minus ion concentration will be equal to minus log Kw. Now we got to know minus log H plus ion concentration is pH and minus log OH minus is the pOH. Then minus log Kw will be the pKw. pKw. Now we know pKw will be equal to minus log Kw at 25 degrees Celsius. What is the Kw value? 10 to the power minus 14. 10 to the power minus 14, pKw will be equal to 14. pKw will be equal to 14, right? Now this is the formula we got at 25 degrees Celsius. Now sir, this formula we got. Now how this formula has came? Now this formula we got on the basis of, now we see, on the basis of for conjugate acid and the conjugate base. For a conjugate acid, and conjugate base. For a conjugate acid and the conjugate base. Clear? For a conjugate acid and the conjugate base, if you take, now in that you will get to know what is the conjugate acid and the conjugate base. Here for a conjugate acid and the conjugate base, here HA is a weak acid. Now if you add this weak acid in the water, now how it will be dissociate? It will be HA plus and the A minus. It will become H3O plus. It will become H3O plus, right? Done. Now this HA plus is the which one? Conjugate base or conjugate acid? This A minus, sorry, this H3O plus and the A minus. Oh, this is the acid, right? Acid has been converted into its respective ion. This is the acid dissociation constant. Then we can write it as a concentration of hydronium ion and the concentration of its conjugate base by concentration of its acid. This is 1. Done. Next, again this conjugate base, again it will be react with the water. What it will do? It will react with the water. Now this A minus, when it has reacted with the water, now again it will be converted into the HA plus OH minus. HA plus OH minus. Now it will become the Kb. Now Kb will be equal to concentration of HA and concentration of OH minus by concentration of A minus. Right? Now this is a 2. This is a 2. Now from 192, Ka into Kb. Ka into Kb. Now we know Ka is equal to H3O plus and A minus by HA into OH minus by A minus. Right? Now A minus will be cancelled. HA will be cancelled. Now Ka into Kb will be equal to hydronium ion concentration. Hydronium ion concentration is nothing but H plus ion concentration only, minus OH minus ion concentration. This, if you apply the negative log on the both sides for this one will become Ka into Kb will be equal to Kw. For this one, if you apply a negative log on both sides, you will get the pKa plus pKb will be equal to pKw, that it will be equal to 14. Right? We got to know this formula, and this formula is applicable at 25 degrees Celsius. This you have to be very careful. Temperature will play very crucial role. Here what it will play? temperature will play very crucial role. Now we are going to solve the what pH of the strong acid and the strong base. pH of the strong acid and the strong base if they have given. Then here many of the students they will get confused to calculate the pH. Here normally first the pH of the strong acid and the strong base they have given. pH of strong acid and the strong base. Strong acid and the strong base if they have given, then the pH of the strong acid and the strong base if they have given. In the aqueous solution if they have given, then the what is the resultant pH we have to consider and when we should not consider for that one. Here let's suppose HCl aqueous solution, it is having 10 to the power minus 2 molar concentration. What is its pH if they have given? Then this is a H2O. This is a H2O, right? Now in this H2O, before at 25 degrees Celsius, at 25 degrees Celsius in this H2O we are having the H plus ion concentration and OH minus ion concentration, that is of 10 to the power minus 7 molar. 10 to the power minus 7 molar. Clear? Now in this aqueous solution I am going to add the HCl. This whose HCl H plus ion concentration is 10 to the power minus 2 molar. 10 to the power minus 2 molar. Now in this aqueous solution what we are having? In this aqueous solution one H plus ion concentration which it has came from the HCl, that it is 10 to the power minus 2, and another already it is having the H plus ion concentration of H2O which is the 10 to the power minus 7 molar. Now you see, in comparison with the 10 to the power minus 7 molar which has came from the strong acid and already which it is present 10 to the power minus 7 molar in the solution, in comparison with the strong acid H plus ion concentration, now this aqueous solution H plus ion concentration can be neglected. So there is no any role of this H plus ion concentration will do when you add the 10 to the power minus 2 molar of strong acid in the aqueous solution. Then its resultant pH will be equal to log 10 to the power minus 2, then the pH will be equal to 2. This is the first key point you have to remember. This is a first key point, right? Here if any acids H plus ion concentration is 10 to the power minus 2, or in comparison to the 10 to the power minus 2, 10 to the power minus 2 molar is higher than the 10 to the power minus 7 molar of the H2O, so it can be neglected. So up to which solution we can neglect? Sir, up to which solution we can neglect means here the strong acid is only the significant source of H3O plus unless the solution extremely dilute to the less than or equal to the 10 to the power minus 6 molar. Clear? Means when to consider the H plus ion concentration, sir, of H2O means if strong acid is diluted up to 10 to the power minus 6 molar, up to 10 to the power minus 6 molar. Clear? Up to the 10 to the power minus 6 molar if you dilute, means up to the 10 to the power minus 7 molar of strong acid they have given in the aqueous solution, HCl aqueous solution they have given. Now the resultant pH will become 5. If suppose that strong acid H plus ion concentration is 10 to the power minus 6 they have given, then we have to consider strong acid is diluted up to 10 to the power minus 6 molar, then we have to consider both which one? H plus ion concentration of acid and H plus ion concentration of H2O. Okay, this is a one key point you have to remember. If the strong acid H plus ion concentration is 10 to the power minus 5 molar, no need to consider the which one? H2O H plus ion concentration. Okay, if the 10 to the power minus 5 molar of the strong acid, no need to consider H plus of H2O. No need to consider H plus of H2O. I hope it is clear. Then next one. If the same base also same. If the strong base is only the significant source of OH minus, unless the solution is extremely diluted to the what OH minus ion concentration is less than 10 to the power minus 6 molar. For the base also same. For the neutral solution, for the if a strong base is diluted, the strong base is diluted up to 10 to the power minus 6 molar. Okay, 10 to the power minus 6 molar. Then no need to consider the OH minus ion concentration of the neutral solution. Means here these are the two key points when to consider the H plus and when to not consider the H plus ion and the OH minus. Clear? Let's suppose depending upon the questions, I will give you the questions. Yes. 10 to the power minus 6 to 10 to the power minus 8. 10 to the power minus 6 to 10 to the power minus 8. That only. Compared to the 10 to the power, let's suppose 10 to the power minus 9. Let's suppose 10 to the power minus 9 molar of NaOH if they have given. 10 to the power minus 6 molar is higher, right? 10 to the power minus 6 molar is higher, right? To make you understand, I explained it on the basis of 10 to the power minus 8. Okay? 10 to the power minus 8 only you can take. Okay, don't get confused. 10 to the power extremely diluted to the OH minus ion concentration, that I explained on the basis of H plus ion concentration. Okay? This I explained on the basis of H plus ion concentration. Okay, right. Now, then with the questions we'll do so that everything it will be clear for you. If total hydronium ion concentration and OH minus ion concentration, if the both in the solution, if the H plus ion concentration and the OH minus concentration in mixture of strong acid or strong base, then how to calculate? If the H3O plus resultant solution is higher acidic, then we have to consider N acidic versus normality of acid and volume of acid minus N1 V1. Sorry, we have to take it as summation of N V by summation of V. Now OH minus ion concentration, summation of NV, NB, VB by VB, NA, VA by VA. Clear? Now let's suppose, then if the solution is neutral, if this solution is neutral, then the resultant solution, if suppose the resultant solution, if it is neutral, then we can say N1 V1 is equal to N2 V2. The resultant solution is neutral, N1 V1 is equal to N2 V2. In this manner we can calculate. Let's suppose if the resultant solution strong acid plus strong base is mixed, then let's suppose we'll say 0.2 molar of 200 ml HCl is mixed with 0.1 molar of 200 ml NaOH. Now the resultant solution is acidic or basic. If strong acid plus strong base is mixed, 0.2 molar of 200 ml of HCl is mixed with 0.1 molar of NaOH. Now resultant solution is acidic or basic? Good. Resultant solution is acidic and resultant solution is acidic. Okay. Resultant solution is acidic and resultant solution pH. And resultant solution pH. What is the pH? Resultant solution pH. Resultant solution pH. I need the resultant solution pH. So whenever this type of the question they have given, sir, how to solve? Sir, how we can say whether the resultant solution is acidic or not? We know 0.2 into 10 to the 200. 0.2 into 200, it will be the 40 moles. So HCl 0.2 into, it will become 2 into 20, that it will become 40. 40 moles, millimoles of HCl reacted with 20 millimoles of NaOH to give the which one? To give which one? NaCl. NaCl is a neutral salt. Its pH is 7. No role of the NaCl will do. So for the 40, 20 moles of NaOH required means here the 20 moles of salt will form and the 20 millimoles of HCl will be left. 20 millimoles of the HCl will be left at the solution. Means the resultant solution is acidic, right? If the resultant solution is acidic, then here resultant solution, if it is acidic, if solution is acidic, if the solution is acidic, then NaVa, normality of acid and volume of acid, is greater than normality of base and the volume of base. Then the resultant H plus ion concentration of its solution will be calculated on the basis of NaVa minus NbVb by V1 plus V2. V1 plus V2 or N1 V1 minus N2 V2 by V1 plus V2 also you can take if you are having. Then here how much you will get? 40 minus 20 by total how much? 100. 200 plus 200, 400. Total it will be the 400. Then I am asking pH. You have said only N1 V1 by N2 V2. Then I am asking resultant pH of the solution. Then it will become 20 by 400. It will be cancelled and it will be the 2 by 20, 1 by 20, 1 by 20. 1 by 20 will be how much? 1 by 20 will be how much? 1 by 20 will be 1, 0, 0 and it will be the 0.05. It will be the 0.05. 0.05 will be 1 by 20. 1 by 20 will be the first is 0 point again 0. It will be the 5. It will be the 5.10 to the power minus 2. 5.10 to the power minus 2 means H plus ion concentration we got it as a 5 into 10 to the power minus 2. Then the pH will be 2 minus log 5. 2 minus log 5 will be 1.3. Now the resultant solution pH will be 1.3. Okay. Now the resultant solution pH will be 1.3. Okay. In this manner they will ask. If next one. Now the next question. Same question only with the different data. If the 0.5 molar of NaOH reacted with 0.2 molar of HCl. Now resultant solution and pH. Resultant solution and the pH. I am asking pH. Okay, don't be in a hurry to give the answer. I am asking pH. Now say me the answer. I am asking the pH. What is the pH? What is the pH? pH is 13.3. 13.13. Okay. Oh, sorry. I did not give the any volume terms, huh? Okay, directly I was given the molarity. If I was not given, okay, I better you take the 500 and 500. 500 and the 1 liter you took, good. Okay, fine. Sir, 1 liter you took. 1 liter you have taken. Okay, fine. 1 liter you have taken. Done. Total it will be the 2. Okay, fine. Based on the 1 liter you have did. Good. Okay, fine. Then it will become 0.5 into 10 to the power minus 1 plus 2 into 10 to the power minus 1 by 2000. Then if you do, you will get the POH. Actually, this is a then the resultant solution POH you will get minus. If you do, you will get the answer. Then you will get the POH minus and concentration from here. 10 this one, right? 5 into 0.5. Now here, now the resultant solution is basic, right? NaOH plus HCl gives rise to NaCl. Then for the 1 moles it required 1. Then 0.5 required 0.5, but it is having 0.2. Then the leftover is 0.3 molar of NaOH, means resultant solution is basic. Then the resultant solution is basic. The OH minus ion concentration will be NbVb minus NaVa by Va plus Vb, right? Va plus Vb. No. 5 into 10 to the power minus 1 I wrote. Then it will be the 5 into 10 to the power minus 1 minus 2 into 10 to the power minus 1 by 2000. Or if you take 2 directly if you want to do in the later, better if you take 1 liter and it will become 2000 ml. Then 2 liter if you take also, no problem. Then in this manner you can calculate. Then you can calculate the form of the concentration, right? Now the resultant solution pH. Now I will give you the question. Now for this question, now you have to say me the answer. Okay, for this question you have to say me the answer. Now what is the question they have given? The question they have given, wait, let me check. Yeah. Calculate the pH of first one, 10 to the power minus 3 molar H2SO4. Okay, 10 to the power minus 3 molar H2SO4, and B 0.3 into 10 to the power minus 3 molar calcium hydroxide. Now see me the answer. Don't search in any Google or anywhere. Try to do it by your own and say me the answer. If you are not getting, I am ready to explain. Okay. First one is 2.7. First one is 2.7. How come it is a 2.7? How come it is a 2.7? Because 10 to the power minus 3 molar, right? So actually the first one, the answer should be 3, right? Because H plus ion concentration of the H2SO4 is good. See here, many of the students, if they have given H2SO4, directly they will think that from the H2SO4 H plus ion concentration will be there. Now pH will be equal to minus log of H plus ion concentration, that is 10 to the power minus 3. So they will think that the answer is pH is 3. But in your options also this one will be there 3. But actually the 3 is not the, but 3 is not the, the 3 is not the pH. You have to be very careful. What we have to be very careful? This is H2SO4 and he has given the molarity. Now we know the pH, right? What is the pH formula? pH is equal to minus log of H plus ion concentration of its normality. H plus ion concentration of its normality. But here they have given it as a molarity. Normality, we have to convert that H plus ion concentration of its normality into molarity, means molarity into n factor. Molarity is a 10 to the power minus 3 and the n factor of the H2SO4 is 2. Clear? Then pH will be equal to minus log of 2 into 10 to the power minus 3. So the pH will be equal to the 3 minus log 2. 3 minus log 2 will be the 2.7. 2.7. Okay. I know many of the students, they will think that it is a pH will be the log 3, but pH is not the log 3. Okay, this is H2. Next one, second one will be the 10 to the power 10.67. No, 10.67. Second one pH is 10.67. Approx 10.67. How? You can see here. Here you may think that its pH will be calcium hydroxide. Now POH, calcium hydroxide, will be, it is a strong electrolyte. It will be dissociated as a Ca plus 2 and the 2OH minus 2. Correct only. pH is correct only. 10.67 only. I mean 10.78 you will get answer. 10.78. Now this is a strong electrolyte. Now its concentration is 10 to the power how much? Minus 3 into 10 to the power minus 4 you will get. This is 3 into 10 to the power minus 7 molar. But here we are having the how much? 2 OH minus ions, right? 2 into 3 into 10 to the power minus 7 molar means 6 into 10 to the power minus 4 molar of OH minus concentration. Then the POH will be equal to minus log of 6 into 10 to the power minus 4 molar. Because OH minus POH formula, POH will be equal to minus log of OH minus ion, its concentration of its normality. Then it will become POH will be equal to 14 minus log 6. 14 minus 4 not 14, 4 minus log 6. 4 minus log 6. Log 6 is nothing but 0.6. 0.6 will be equal to 3.4. 3.4 and the pH plus POH will be equal to 14. Then pH will be equal to 10.6. 10.6. Okay, clear? Now Titan, hi Titan, hi. Then clear? Now in this manner you have to calculate the pH. So you have to be very careful with this type of the questions they have given. Next one, I will give you some calculation part. You have to send me the answers. Now calculate the concentration of hydrogen ion in a acidic solution. Calculate the concentration of acidic solution with pH. First one, A, it is having the 4.3. A pH, it is having the 4.3. Now say me the answer. Calculate the concentration of H plus ion. Calculate the concentration of the H plus ion whose pH is 4.3. How much is the concentration of the H plus ion whose pH is 4.3? Now the answer will be the 10 to the power 5 into 10 to the power minus 4. How come 5 into 10 to the power minus 4? How come 5 into 10 to the power minus 10 to the power minus 5? Now pH will be equal to minus log of base 10 H plus ion concentration, right? Now if you send the minus log base 10 to the left hand side, then the H plus ion concentration will be equal to 10 to the power minus 4.3. 10 to the power minus 4.3. Then if you solve this one, you will get the H plus ion concentration. Then you will get the H plus ion concentration. Okay. Now next one, the very important concept, the questions we are going to do. I will give you the questions. Now you have to solve the answers. Okay. Don't be in hurry. See the question carefully. See the question carefully and solve. Whether they have given the normality or whether they have given the base or whether they have given anything. 5 into 10 to the power minus 5. Oh, minus 5. Then, okay. Now, we'll see. Here, the question I am going to give you is 500 ml of 0.1 molar HCl plus 100 ml of 0.1 normal H3PO4 plus, right, plus 400 ml of 0.1 normal calcium hydroxide. Calculate pH of solution. Calculate the pH of the solution. Now say me the answer. Calculate the pH for this one and say me the answer. Calculate the pH of the solution. Calculate the pH of the solution. Calculate the pH of the solution. .3. The resultant pH is 12.3. How Pranit, how? How it is the 12.3? First of all, you say me the resultant solution is acidic or basic. First you say me the resultant solution. Okay. Don't say that one. If you say whether the resultant I am asking whether the resultant solution is acidic or basic. Whether okay, good. If the resultant solution, if it is a basic only, then you will get the pH that much. How come? Here HCl acid we are having. HCl acid we are having and H3PO4 also acid we are having. Now millimoles, milli equivalents of the HCl if you take, that you will get it as a 50 milli equivalents you will get. Then already they have given the normality, right? So no need to take its n factor. Directly you will get it as a 10 millimoles. Then total acid millimoles will be the 60 milli equivalents or millimoles you will get. Milli equivalents or millimoles you will get. Then after that, next one what we are having? Base calcium hydroxide molarity they have given. Molarity means you have to convert into the normality, right? Molarity means you have to convert into the normality. Molarity converting into the normality, then it is a n factor is 2. Then base calcium hydroxide base, the equivalents you will get it as a millimoles you will get. This also will take moles only. Okay, 80 millimoles means 20 millimoles of the base will be there in the solution. See, 80 minus 60. 80 minus 60. Now the resultant solution will be the basic. If the resultant solution will be the basic means now you have to calculate the OH minus ion concentration. OH minus ion concentration. So how to calculate the OH minus ion concentration? Now the leftover OH minus ion concentration will be the 20 by the resultant solution will be the 100. The resultant solution will be the 100. Now basic solution, then you will get the 2 into 10 to the power minus 2 of normality. Then POH will get it as a, how much you will get POH? Approx 1.7. Now the pH you will get it as a 12.3. Right? I hope it is clear. I hope it is clear. I hope it is clear. 2 into 10 to the power 3 minus. Okay, correct. Right? 0.14 now. What 0.14? No. Here already they have given normality. Here already they have given normality. So if they have given the normality, no need of considering the n factor. No need of considering the n factor. Okay, fine. Next question. Next question I will give you. So based on this, I hope you will do, but try to do it by your end. Now the question he has given 8 gram of NaOH, 8 gram of NaOH plus 680 ml of 1 molar HCl plus 10 ml of H2SO4, 10 ml of H2SO4. Its density is equal to 1.2 and 49% of H2SO4 by weight. Clear? Now total volume of solution was made to 1 liter. Now pH of the solution. Now say me the answer. pH of the solution. What is the pH of the solution? What is the pH of the solution? No, mains question only. It is not the advanced one, mains only. This is not the mains one, this is a NEET question. This is previous year NEET question. You are saying it as advanced. This is NEET question. Same, nothing is there. Why you are getting confusion? Calculate the normalities. You will get the answer. Molarity if you get, convert into the normality with the n factors. Convert into the normalities with the n factors, you will get the answer. NaOH volume, millimoles you take. No need of NaOH volume. Millimoles you take. Already I have given, I made it up to the 1 liter, right? Means already here the 680 ml, here the 10 ml. 680 ml, here the 1080 ml means total 690 ml. Leftover volume will be of the NaOH only, right? Already the volume 1000 ml I made. So the final solution will be the 1000 ml. So why you are getting confusion? So no need of NaOH volume. Now try to do. Calculate the millimoles millimoles of the each of the following. Then after that, then you will get the answer. Normality relation you have to use. Better use the normality relation. Normal. Okay, molarity relation if you use also you will get the answer. But n factor you have to multiply. After getting the molarity, for that molarity you have to multiply n factor. That only molarity is equal to weight by weight percentage into density into 10 by molecular weight for the molarity. For the direct normality, weight by weight percentage into 10 into density by equivalent weight, gram equivalent weight. That's it. If you take it on the molarity also, you will get the answer, but you have to multiply n factor to convert into normality. If you do it directly normality, no need of multiplying the n factor. Some lengthy calculation you will get, I think so. Better you do this question and answer the this question answer in the comment section. Okay, I will cross check because we have to cover the more number of topics. So I am moving. Try to solve it by your own. You can solve it after the concept. I mean, after the live ends, then go to this question and solve that and answer that comment in the comment section, because we have to cover the n number of concepts. Okay, right. Next, here next one, the next concept we are going to see, if the next, if HCl aqueous solution concentration is 10 to the power minus 7 molar. Now the resultant solution pH will be, if the H plus ion concentration is this much, then what is the resultant pH? What is the resultant pH? Now we have to consider here the in the aqueous solution already 10 to the power minus 7 molar of H2O is there. H2O H plus ion concentration is there. HCl H plus ion concentration is also same. Yes, both are, we have to consider both. So then pH will be equal to minus log of 10 to the power minus 7 molar of HCl plus 10 to the power minus 7 molar of H2O. Both you have to consider. Then if you take one 10 to the power minus 7 molar as a common, then it will be equal to the how much? 1 plus 1. 1 plus 1. Then it will become 2. So minus log of 2 into 10 to the power minus 7. That it will be equal to 7 minus log 2. 7 minus log 2 will be equal to 6.7. So if the H plus ion concentration 10 to the power minus 7 molar, 10 to the power minus 6, 10 to the power minus 8 if they have given, we have to consider the H plus ion concentration of H2O. So this is a 6.7. Okay. Right. Done. No, next. Done. Okay, fine. Now the next one, we are going to see the pH formulas for the different acids. pH formulas for the different acids we are going to see. Now the first pH for determination of pH of acids and bases. Determination of pH of acids and the bases. Now you see, first one we are going to see for the strong acids. Strong acids pH will be, strong acids, first one, the strong acids pH. Now the strong acids pH will be calculated on the basis of minus log of H plus ion concentration of its normality, we know, right? Now here in comparison with a strong acid H plus ion concentration of its normality, H2O H plus ion concentration of its normality is neglected in the strong acid. Directly by this formula we can calculate the strong acid pH. Next, if suppose weak acid they have given, second one, weak acid pH. How to calculate the weak acid pH? So the weak acid pH will be given. Now this is the one weak acid HA. Now this HA will be converted into the HA plus and A minus and the A minus, right? If the time t is equal to 0, this is C concentration 0 0, right? Now at a time t equilibrium, C into 1 minus alpha, C alpha, C alpha, right? C into 1 minus alpha, C alpha and the C alpha, right? Now next one minute. Here, whenever, my dear friends, many of the students they are getting confusion whenever they have given the weak acid type of the questions. Weak acid type of the questions, if they have given H plus ion concentration of the weak acid, based on this concentration only you have to cross check and you have to solve. Okay. Now here you can see at the equilibrium H plus ion concentration is C into C alpha. Now acid dissociation constant we know C alpha square by 1 minus alpha. Now for the weak electrolyte 1 minus alpha will be tends to 1. Then Ka will be equal to C alpha square. C alpha square. Done. Now if it is a C alpha square, for mathematical calculation purpose what I am doing, I was multiplying the C and C to the left hand side, both on the both sides. Then what it will happen, C square into alpha square will be the concentration of the H plus, because we need the pH. To need the pH, we should know the H plus ion concentration of the acid. We should know the H plus ion concentration of the acid. To know the H plus ion concentration of the acid, then can I say like this, H plus ion concentration whole square is equal to C into Ka. C into Ka. Then H plus ion concentration will be equal to root C into Ka. Root C into Ka. Now apply minus log on both sides. Minus log on both sides. If you apply minus log on the both sides, now the formula will become, what the formula will become? What? pH will be equal to half pKa minus log C. Directly I was writing because no need of the derivation part. We required only the, which one? Weak acid pH. This is a weak acid pH. Now in the same way, for the weak base if they ask, POH is equal to half pKb minus log C. Half pKb minus log C. Okay. Now based on this formulas, now I will give you one question. Now you have to say me the answer. Now weak acid concentration is 0.1 molar and its dissociation is 0.01%. Now calculate the pH of the solution. calculate the pH of the solution. Same is the answer. Calculate the pH of the solution. Calculate the pH of the solution. What is the pH of this solution? What is the pH of the solution? If you know, try to say. If not, give me the question mark. I'm ready to explain. But don't search in any Google or somewhere. What is the resultant pH? What is the resultant pH? What is the resultant pH of the solution? Are you trying or not? No. No. Here they have not given any pKa value, right? Then if they have not given any pKa value, how to calculate the pH? Then how you will use that formula? How you will use that formula if they have not given any pKa means? If you don't know means, now I will ready to explain. Now listen. Here, wait, I will explain next. Now this type of the questions, if they are given, what you have to do first, weak acid, right? This is the HA is the weak acid. Then it will be converted into the H plus and the A minus. Now the H plus concentration will be the C alpha, right? H plus and concentration will be the C alpha. Now he is asking the resultant solution pH. Now pH will be equal to the minus log of H plus ion concentration of that solution. Now the H plus ion concentration, here alpha they have given, dissociation they have given, concentration they have given. From here H plus ion concentration will be equal to 0.1 into 0.01 by 100, because 0.01 percentage they have given. You have to convert it into the alpha. Then how much it will become H plus ion concentration? It will become 10 to the power minus 2. This will become 1 into 10 to the power minus 1, and that one will become 10 to the power minus 2, and this will be the 10 to the power minus 2. Overall will become how much? Overall will become 10 to the power minus 6. And then 10 to the power minus 1, minus 3, total overall will become 10 to the power minus 6. So the pH will be equal to 6. pH will be equal to 6. I hope it is clear. Minus 5, sir. 10 to the power minus 5. Minus, oh sorry, this is 10 to the power minus 2, no? Oh sorry. 10 to the power minus 2. So the overall pH will be 5. Overall pH will be 5. Okay, sorry. I took the 10 to the power 100 as a 10 to the power minus 5. The overall pH will be 5. Okay, is it clear? In this manner you have to solve. If this type of the question they have given, weak acid means you have to take the constant dissociation. If they have given in the question means dissociation they have given in the question means acids dissociation will be C into alpha, right? So alpha they have given, concentration they have given, you will get the H plus ion. That if you put it in the pH you will get the answer. Okay na? I hope it is clear. Now we'll see one question based on this one. Any questions they have given? Let's cross check whether they are okay. Okay, now we'll see. First we'll complete the concept. After that we'll cross check the questions. Then after that, next one. The next type we are having the pH of mixture of acids. If suppose if they have given the mixture of acids if they have given, now I am not going completely the derivation part. because if I do the derivation part, it will take the much time. Just I will explain the concept, how that formula it is coming. Here the H plus and the A minus. This is a one weak acid. In that weak acid, initially this weak acid concentration is C1. This is 0, this is 0. Now when it has reached the equilibrium, from the C1 concentration, 1 minus alpha 1 has been dissociated, C1 alpha has been formed. Okay, C1 alpha 1 has been formed. For this weak acid, another weak acid we are going to add, that it is a HB, right? Now it will be converted into the H plus ion concentration and the B minus ion concentration plus, right? Now initially at a time 2 is equal to 0, its C2 concentration is there, 0, 0. When it has reached to the equilibrium, from the C2, 1 minus alpha 2 has been dissociated, C2 alpha 2 and the C2 alpha 2 has been formed. Now here for the same solution, both the common ions should not have the different concentration, right? Already I explained very clearly. For the same solution, two ions should not have the different concentration. Then it will become the C2 alpha 2. Now this one will become the C1 alpha 1. Clear? Then if I write the Ka1 for this one, if I write the Ka2 for this one, then what I can write? Ka1 will be equal to concentration of H plus ion and A minus ion by HA. Then Ka2 will be equal to concentration of H plus ion and B minus ion by HB, right? Then if I multiply Ka1 into Ka2, if I multiply the Ka1 into the Ka2, then I will get the pH formula. This is somewhat you can eliminate. Directly you will get the H plus ion concentration. How the H plus ion concentration you will get? Ka1 and the Ka2 if you multiply, here what it will be there? This A minus ion concentration, B minus ion concentration, HA, HB concentration will be cancelled out, and it will give you the H plus whole square. H plus ion whole square. No need of thinking about that how the H plus ion whole square it is there. It is somewhat calculation part. No need of that one. Now the direct pH formula will get pH is equal to minus log of concentration of C1 alpha 1 plus C2 alpha 2. Because H plus ion concentration in the solution we are having C1 alpha 1 plus C2 alpha 2. So for the mixture of acids, pH formula will be minus log of C1 alpha 1 plus C2 alpha 2. That's it. This is a one formula we are having for the mixture of acid. And the next, if suppose they have given the polytropic weak acid. No, half rather. No, how you will get the half? Which one? Here square will be cancelled out. Ikkada H plus ion concentration, this H plus ion concentration, right? Here, okay, you are getting confusion. Ikkada H plus ion concentration kada. Now H plus ion concentration is how much? C1 alpha 1 and the C2 alpha 2 whole square, right? 1 minute. What happened to this one? Wait, I will explain. Now here you can see H plus ion here H plus ion whole square, right? That it will be equal to C1 alpha 1 plus C2 alpha 2 whole square, na? Here the square cancel. Here the square cancel. Because H plus ion concentration in the solution we are having C1 alpha 1 plus C2 alpha 2. Then it will be equal to the which one? H plus alpha square. This one will be the C plus alpha square. This one will be get cancelled. Then if you apply minus log on both sides, if you do minus log, this will become pH. pH will be equal to minus log of C1 alpha 1 plus C2 alpha 2. That's it. Okay. Common ion of H plus ion concentration. Yes. Next one, the another polytropic weak acid we are having. What is the meaning of the polytropic weak acid? Now polytropic weak acid. Polytropic weak acids, if they have given, means what is the meaning of the polytropic weak acid? The acids which are having more than two H plus ion or more than two dissociations, if they have given, that we call it as a polytropic weak acid. Carbonic acid, H2S, these are the polytropic weak acid. This polytropic weak acid pH will be equal to minus log of C1 alpha C into alpha 1 plus C into alpha 1 alpha 2. Okay, no need of the derivation part, just you remember this formula. Okay, now next one. Now I will give you one question, you have to say me the answer. Now what is the question I am going to give you? It is easy only, but don't be rush to give the answer. Just see the question carefully and try to give me the answer. Here, what is the question? What is asking? What amount is asking, nothing but mass. What amount of KOH must be dissolved in a 200 ml of solution, 200 ml of solution that having pH is equal to 12.3. Now say pH is equal to 12.3. pH is equal to 12.3. pH is equal to 12.3. ml of what is the answer you will get? Amount is asking. Amount means mass is asking. Amount is nothing but mass is asking. Amount is nothing but mass. Don't know. Still any other? Simple. Nothing you have to do. What you have to do? First pH they have given. So this is amount is asking on the basis of base. Base means pH plus POH is equal to 14. Now the pH will be, you will get POH you will get it as 1.7. POH you will get it as 1.7. Now the POH will be equal to minus log of OH minus ion concentration of its normality. Okay na, base 10. Then OH minus ion concentration of its normality you will get it as 10 to the power minus 1.7. 10 to the power minus 1.7. Now the 10 to the power minus 1.7 value will give you that normality you will get it as 2 into 10 to the power minus 2 you will get. Okay. This you will get it as a 2 into 10 to the power minus 2. Normality you got. After getting the normality, amount is asking, right? Normality is equal to gram equivalents by volume in ml into 1000. Volume in ml into 1000. But is asking the weight. Weight is equal to normality is equal to gram equivalents is equal to weight of solute. Weight of solute by equivalent weight. Equivalent weight into 1000 by V in ml. So weight of the solute is asking, right? Then the weight of the solute will be equal to normality into equivalent weight into V in ml by 1000. V in ml by 1000. Normality how much we got? 2 into 10 to the power minus 2. Equivalent weight of the KOH, N factor is 1 means potassium 39, 1 40, 40 plus 16, 56. 56 into 200 ml by 1000. Then if you do 200 cancel, this one will become 5. How much it will become? How much you will get? Calculate it and say me. 56 into equivalent weight of solute, amount of solute added, amount of solute will be equal to N into equivalent weight into V in ml. That if you do, you will get the answer. Okay, this if you solve, you will get the amount you will get. I hope it is clear. How much amount we have added, that you will 0.24 you will get 0.224 grams, you will get 0.224 grams of the weight we have added. Okay, 0.224 grams of the weight we have added. Next one. The next concept that we are going to see, calculation of the pH and concentration of H plus and OH minus. Concentration of the H plus and the OH minus. See, this is also one key point you have to remember. When the equal volumes of two or more solutions, known solutions, or two or more solutions of known pH are mixed, then what happened, H plus ion concentration and OH minus ion concentration will become half, right? Will become half, means total concentration H plus or OH minus will be divided by 2. Clear? Now 3 solutions known pH is mixed. So H plus ion concentration divided by 3. Okay, total H plus ion concentrations are, that one will be H plus ion concentration, better will take like this, H plus ion concentration and OH minus ion concentration should be divided by the 3. Now sir, how to calculate, sir, for this one? Now we'll see. Question will do. With the question you will get understand. Equal volumes of pH 2 and pH 3 are mixed. Equal volumes of pH 2 and the pH 3 are mixed. Now what is the final pH? If they ask what is the final pH? Now we know H plus ion concentration of the pH 2 will be 10 to the power minus 2 and this one will be the 10 to the power minus 3. So equal volumes when they have mixed, then the final concentration will be divided by 2. Means then it will become 10 to the power minus 2. Then it will be the 1 plus 10 to the power minus 1. 1 plus 10 to the power minus 1 by 2. That it will be given as a 0.55 into 10 to the power minus 2. 10 to the power minus 2. 10 to the power minus 2. Then the final concentration will be 2.26. This is on the basis of the calculation. And the trick for this one, trick is, what is the trick means? What is the trick if they have given? If 2 pH difference is 1, if the two pH difference is 1, now the average pH and subtract 0.24 to get exact pH. Means here the pH is equal to 2 and the pH is equal to 3, right? Now its average will be 2 plus 3 by 2. It will be the 2.5. Now 2.5 minus 0.24, if you do, you will get it as a 2.26. So this is a trick, you will get the exact pH, and if you calculate this one also, you will get the 2.26. Both the cases you will get the 2.26, right? Next one. Next, if the three solutions pH they have given, if the three solutions pH means pH is equal to 1, if the pH is equal to 2, if the pH is equal to 3, then average you do. For this one directly I will share the shortcut, no need of remembering anything. Now if the three known solutions if they have given, for that resultant pH, how much you have to do minus? If the three resultant solutions pH difference is 1, then for that the resultant pH, what you have to do, take the average 3 plus 2 plus 1 by 3, then it will become 2, right? For this one 2, you have to minus 0.56 to get the exact pH, that it will be equal to 1.44, right? Now if you do it in this manner also, you will get how 10 to the power minus 1 plus 10 to the power minus 2 plus 10 to the power minus 3 by 3, then 10 to the power minus 1 by 3 into 1 plus 0.1 plus 100, if you do, you will get same calculation, same pH you will get. With the trick you will get the same, and by the calculation also you will get the same. I hope it is clear. I hope it is clear with the trick and the concept. It is clear. Right. Still anyone is in the live? If anyone is in the live, just say me hi, so that I can, based on that one, whether to start the questions or whether to start the another topic, we'll see. Okay, now just we'll take the 5 minutes break, because almost the pH formulas has been done. Then after the pH formulas, next we are going to see the salt hydrolysis and the buffer. This will play very, very crucial role. So the 10 minutes break will take, and the 8:20 will start. 8:20 will start the class. 10 minutes break. 8:25 will start. Better 8:25 will start. 15 minutes break will take. 15 minutes break will take, and 8:25 will start. Okay, right? Next one will be the salt hydrolysis, because salt hydrolysis concept is very, very important. Just because you have to listen that concept with the fresh mind, that's the reason I am giving the 15 minutes break. Okay, now exactly 8:25 will start the class with the salt hydrolysis. Hello. Anyone is in live? Hello. Anyone is in live? If anyone is in the live, just say me hi. Good. Fine. Now, right, still any other? Still any other or there in the live? Now I just stopped the video. Now we'll start the next very important concept that we are having, that it is a salt hydrolysis. I hope the voice is clear, right? Voice in the video is clear. I hope the video and the audio is clear. Once if you say me whether the video and audio is clear, so that I can start the next very important concept that we are going to study, that is a salt hydrolysis and pH of their solutions Okay, now salt hydrolysis and pH of their solutions. Okay, done. Now next, salt hydrolysis and the pH of the solutions. Here we are having, now what is the meaning of the salt hydrolysis and what we are going to see. Salt hydrolysis nothing but, here when the salt, when we have dissolved in the water, that respective cation when it has reacted with the water, that we call it as a salt hydrolysis. So here we are going to see the first types of the salts. Now what are the types of the salts we are having? First, if these types of the salts, if it is clear, then the salt hydrolysis will be clear for us. So in these types of the salts, first one, the first type of the salt we are having strong acid plus strong base. Strong acid plus strong base salt we are going to see, that it is a example NaCl, CaCl2, clear. Next BaCl2, right. Next KCl, next NaNO3, clear. Next Na2SO4, right. Calcium nitrate, NaCa, NO3 taken twice. These are the examples for the strong acid versus strong base salts. Clear. Now the one thing, the very key point you have to remember for this type of the salts, if they have given near this type of these salts, if we have added in the water, let's suppose the NaCl will take this NaCl, what we have did, we have added in the water. Now this NaCl when we have added in the water, how it will be dissociate? It will be dissociate as a Na plus and the Cl minus. Na plus and the Cl minus. Clear. Now this Na plus, let's suppose hydrolysis we are saying, right, salt hydrolysis. So from the salt, whatever may be the cation and the anion it has came, that if it is reacted with the water, what is the resultant pH, change in pH of that solution we have to calculate. Clear. For NaCl when I have added in the water, this Na plus, if it is reacted with the water, now what it will be converted? It will be converted into the NaOH plus H plus. NaOH plus H plus, right. Now this NaOH is a strong electrolyte, we know. That strong electrolyte, again it will be the further dissociate in the Na plus and the OH minus. Now you can see, again these two combines will form the H2O. Again the leftover will be the Na plus. See, are we seeing any change in the pH? Whatever we have taken in the starting, the same it is there in the product side also. reactant side and the product side both are same. Reactant side and the product side both are same, right? Then can we see any change in pH? There is no any change in pH. Now if you see it for the Cl minus, Cl minus, if it is reacted with the water, then it will be converted into the HCl and it is a OH minus. Now HCl is a strong electrolyte, again it will be converted into the H plus and it will be converted into Cl minus and the H plus. Now again you see this H plus and the OH minus, again it will react to give the H2O, and the resultant solution we are having the H2O and the Cl. What it is there in the reactant side, the same it is there in the product side. Then for the strong acid versus strong base, we can say that cation part and anion part, cation part and anion part will not react with water, will not react with water. Now this is a key point you have to, this is a key point you have to remember. This is a key point you have to remember. This is a key point you have to remember. Cationic part and the anionic part will not react with water. Clear? Next. Next one. Second type of the salt we are having, salt of strong acid plus weak base. Strong acid plus weak base, if we are having, the type of the salt we are having, ammonium chloride, AlCl3, ZnCl2, FeCl3. Clear? Now in this case weak base cationic part, weak base cationic part, weak base cationic part react with water, strong acid anionic part will not react with water, will not react with water. I hope it is clear. Sir, how sir? Now I will explain. As of now you just remember the salts. Now third one we are having salts of weak acid plus strong base, salts of weak acid plus strong base. Example, CH3COO Na, Na2CO3, K2CO3, KCl. These are the example for the which one? Salts of weak acid and the strong base. Now in this one what we are having? Weak acid anionic part, react with water, weak acid anionic part react with water. Now strong base cationic part will not react with water, Clear? Now this is a one key points you have to remember. Now if you remember this one, directly you can predict the question whatever they may ask. Next, fourth type of the salt we are having, salt of weak acid plus weak base, example CH3COO NH4. Now in this weak base cationic part and weak base cationic part and weak acid anionic part, both will react with water, both will react with the water. So when they are reacting with the water, how the resultant pH will be changing of that solution, how the resultant pH will not change. Now that we are going to see. First one for the strong acid versus strong base. Now before going that one, now I will explain which cation or anion will react with the water, which cation and anion will not react with the water. Now we are going to see. Now strong acid anion and strong base cation. Strong base cation. These two will not react with water, right? Will not react with water. Will not react with H2O. Now example. Now strong acid anion. Strong acid anion. Examples are I minus. Now Br minus, Cl minus, SO4 minus 2. Now NO3 minus, comma ClO4 minus, etc. Right? Next, strong base cation. Strong base cation. Strong base cation will be Na plus, comma K plus, comma Mg plus 2, comma now Ba plus 2, etc. These are the, now this strong acid cation and the strong base anion will not be react with the water. Now which one will be react with the water? Now weak acid anion. Weak acid anion. What are the weak acid anion we are having? That it is CH3 COO minus, CO3 minus 2. Now HCO3 minus. These are the weak acid anion will react with the water. Now weak base cation. Weak base cation. Weak base cation, what we are having? That it is a weak base cation. That is a NH4 plus and Al plus 3, Zn plus 2 and Fe plus 3. This will react with the water. Done? Now we'll see the how the resultant solution pH will be changing according to the given salt. First one, salt of strong acid, salt of strong acid versus strong base we have seen. Then its resultant solution is not changing. That's the reason its pH is 7. Now we'll see the salt of weak acid and strong base, and salt of weak acid and strong base and its resultant pH. Okay. Now if anyone is in live, just say me hi. Just say me hi, so that in the middle of the derivation I can ask some questions so that you can give me the answers. Okay, fine. Pranit, you are there. Done. Good. Now you can see salt of weak acid versus weak base. If they have given salt of weak acid versus weak base, we are having the CH3COO Na. Right? Now this is a strong electrolyte, either in a cationic part or anionic part. If it has came from strong acid or strong base, that it will be a strong electrolyte. Now this salt, when we have added in the water, it will be converted into the acetate ion and the Na plus. Right? Now what I said, strong acid strong base cationic part will not react with H2O. Will not react with H2O. But this acetate ion will react with H2O. Will react with H2O. If it is reacting with the H2O, what it will happen? Now CH3 COO minus plus H2O when it has reacted, and this one we call it as a hydrolysis. This one we call it as a hydrolysis. Salt anionic part is reacting with the water. That's the reason we are saying it as a hydrolysis. When it has reacted with the hydrolysis, now you can see the leftover solution. The leftover solution we are having the NaOH, means we can say the resultant solution is a basic. So the resultant solution is basic, means pH should be greater than 7 or less than 7. Then in the solution Na plus we are having, OH minus we are having. Then the resultant solution is a acidic or basic? Resultant solution is acidic or basic? Resultant solution is basic and the pH should be greater than 7. Right? Now this is a salt. Where salt anion, when it is reacted with the water, then we can say this as a, then we can say it is a hydrolysis constant. Hydrolysis constant is Kh. Kh is equal to concentration of acetate, concentration of acetic acid by concentration of OH minus by concentration of OH minus by concentration of acetate ion. This is a hydrolysis constant we can write. Then here we are having in the solution, we are having the weak acid, right? This weak acid also further dissociated. This weak acid also further dissociated. How the further dissociated this weak acid, acetate ion and the H plus ion concentration. This is a weak acid, right? We can write it as a Ka. Ka is equal to concentration of acetate ion and concentration of H plus ion by concentration of acetic acid. Concentration of acetic acid. Now if you multiply the which one? Kh into Ka. Kh into Ka. That it will be equal to Kw. Sir, how it will be equal to the Kw means, you can see Kh is equal to, what is the Kh we are having? Concentration of acetic acid, OH minus acetate ion. See here you can see acetate ion, CH3OH, that it will be cancelled out and the leftover will be the H plus ion concentration, OH minus ion concentration, that it will be equal to the Kh into Ka is equal to Kw. I hope it is clear. Now we can say Kh is equal to Kw by Ka. This is a one very important relation we are having for the salt of weak acid versus strong base. Kh is equal to Kw by Ka. Done. Then after that, next we are going to see hydrolysis constant. When this acetate ion has been reacted with the water, how much is the hydrolysis constant it is having? Hydrolysis, H and hydrolysis constant, C and a concentration will take, right? Wait, that only I will say, wait. Now this acetate ion, if it is reacted with the H2O, it is converting into the acetic acid. And it is OH minus, right? Now you see, initially acetic acid C concentration, C minus alpha. For the acids we are going to take, but here hydrolysis, right? So we are going to take the C0 initially. From the C, some 1 minus H alpha, CH will be in the place of alpha. In the place of degree of dissociation, we are saying it as a hydrolysis. So Kh is equal to CH square by 1 minus H. Now hydrolysis constant, if it is less than 1, same degree of dissociation only, then it will be tends to the 1. Then H will be equal to under root Kh by C. Now this is a hydrolysis constant you have to remember. Degree of hydrolysis. Yes. H is nothing but degree of hydrolysis. Right? Now, then here the H is equal to under root Kh by C. Then after that we need the pH, right? To need the pH, what we should know? We should know the H plus ion concentration. So H plus ion concentration, where we are having? The H plus ion concentration we are having in the Ka. So from that Ka we need the H plus ion concentration. So how to get the H plus ion concentration? Ka is equal to concentration of acetate ion by concentration of H plus by concentration of acetic acid. Then if you interchange this one, what it will happen? H plus ion concentration will be equal to, what it will happen? Ka into concentration of acetic acid by concentration of acetate ion. Concentration of acetic acid by concentration of acetate ion. Right? Now concentration of the acetic acid, how much we are having? H plus ion concentration is equal to Ka into concentration of acetate ion. How much we got? Concentration of acetic acid. Concentration of acetic acid is CH. Right? Concentration of the acetic acid will be the CH. Now concentration of the acetate ion will be the C into 1 minus H. Now CH by C into 1 minus H. Right? Now here the CC will be get cancelled. Then we can write it as a Ka into H by 1 minus H. Now here the 1 minus H will be tends to the 1 because degree of hydrolysis is 1. Then we can write H plus ion concentration will be equal to Ka into H. Now here the H what we got? H is equal to under root Kh by C, right? So H plus ion concentration, what we can write? H plus ion concentration is equal to Ka into under root H by C. Under root Kh by C. Then Then for this one, can I write like this? Root Ka whole square, root Ka whole square. Both it will become, say, right, into under root Kh by C. Then H plus ion concentration we can write in this manner, right? Under root Ka into Ka whole square into Kh by C. Kh by C. Done. Up to now it is clear. Now the Kh what we are having? Kh is equal to Kw by Ka. Kh is equal to Kw by Ka. Kh is equal to Kw by Ka. Then H plus ion concentration will be equal to under root Ka square into Kw by C into Ka. C into Ka. Now Ka 1 Ka square will be get cancelled. Now the H plus ion concentration will become under root Ka into Kw by C. Under root Ka into Kw by C. This is the H plus ion concentration we got. For this H plus ion concentration, if you add the negative log, okay, by apply negative log on both sides, by applying the negative log on the both side, directly I am writing the pH formula. pH is equal to the direct formula, the pH is equal to what we got, 7 plus half pKa plus log C. pKa plus log C. This is a formula we got for the which one? Weak acid plus strong base formula. Okay, now we can see 7 plus we got, right? Something we got the positive value. 7 plus something positive value will get greater than pH 7. I hope it is clear. Now next one. Next one we are having the next type of the salt. We are having salt of strong acid plus weak base. Strong acid plus weak base salt and its resultant pH we are going to see. Then here we are having the ammonium chloride. This is the ammonium chloride. Ammonium chloride, it will be converted into the ammonium ion plus Cl minus. Right? Now this it has came from the strong acid, right? Strong acid anion part will not react with H2O. Now this one will react with the H2O. Now ammonium ion, when it has reacted with the H2O, it will be converted into the ammonium hydroxide plus H. Now you can see in the solution we are having the H plus and the Cl minus. H plus and the Cl minus. Then H plus and the Cl minus. Now the resultant solution is a acidic. Then if the resultant solution is a acidic, then directly I am writing the pH. Same process. Whichever we have derived the above cases, in the same case we are going to derive for the salt of strong acid plus weak base, but only the difference here we are going to see is OH minus ion, because salt base it will be high, right? So from that base you will get, for that base you will get it as a Kb. So directly I am writing. Are you there? Anyone is in the live? Then if you write the hydrolysis constant for this one, Kh will be equal to Kw by Kb. There, sir. Okay, fine. Now if you write the Kh for this one, Kh you will get a Kw by Kb, because base, right? This is the base. Now next, then now H, what you will get? H you will get it as H is equal to under root Kh by C. Then the formula you will get it as resultant solution is acidic, right? So the first POH you will get. POH is equal to 7 plus half pKb plus log C you will get. First you will get it as a POH you will get, but he is asking the pH, right? He is asking the pH. pH is equal to 14. Now you will get the POH. After getting the pH will be equal to 7 minus half pKb plus log C. pKb plus log C will be the formula. This is the formula for the which one? Weak acid. Sorry, this is a formula for the salt of strong acid plus weak base. Salt of this is HCl, strong acid. Now this is a weak base, ammonium hydroxide. These two reacts to give the ammonium chloride. Ammonium chloride, right? I hope it is clear. Now this is a formula. This is a formula for the weak acid plus strong acid plus weak base. Next type of the formula we are having, that it is a next formula we are having salt of weak acid plus weak base. Salt of weak acid plus weak base. Now for the salt of weak acid plus weak base, we are having the salt is ammonium acetate. Ammonium acetate. Ammonium acetate will be converted into the acetate ion plus ammonium ion. Now acetate ion and the ammonium ion both as came from, this has came from the weak acid, this has came from the weak base. This has came from the weak base. Both it will be react with the water, right? Now how it will be react with the water? Now this one will be react with the water to give the, how it will give? Now better I will write here itself. This CH3COO minus, when it has reacted with the water, what it will give? It will give you the acetic acid plus OH minus, right? Then now ammonium ion, this ammonium ion when it has reacted with the H2O, it will be converted into the ammonium hydroxide, and it releases the H plus. Now you can see the resultant solution H and OH minus will be react and it will become the H2O. So the resultant solution the resultant solution pH should be the neutral. Neutral means it should be the 7. So it should be the 7, right? Then its pH formula will be, it's a KH, you have to remember. KH is equal to H square by 1 minus H square. This is a KH formula you have to remember for this one. Now the hydrolysis constant, sorry, not this one. KH is equal to KW by Ka into Kb. This is a KH formula. Now H is equal to, sometimes the H they will ask you, you have to be very careful with that. H is equal to under root KH 1 plus under root KH. This is also one hydrolysis, because while doing the derivation you will get this one. Directly I am saying, because derivation it will take more time. No need of, no one will ask the derivation. Now the pH formula will become pH is equal to 7 plus half pKa minus pKb. pKa minus pKb. This is the one very important formula we are having. These are the salt hydrolysis formulas. The 3 salt hydrolysis formula that you have to remember. Now see, what are the 3 salt hydrolysis formulas? I will write first. Based on that one you will get to know. Now salt of weak acid plus strong base. Now the resultant pH formula will be 7 plus half pKa plus log C, right? This is a formula. Next, salt of strong acid plus weak base. Now the resultant pH formula will be 7 minus half pKb plus log C, right? Now next, salt of weak acid plus weak base. Now its resultant pH will be 7 plus half pKa minus pKb. Okay, now these are the formulas you have to remember. Okay, now these are the formulas you have to remember. Now okay, now let it be these formulas in this manner. I will complete the buffer solution. After completion of the buffer solution, with the mix of the buffer solution and mix of the salt hydrolysis, how they are going to ask the questions. Now that questions we will do. Okay, now the next question, the next concept that we are going to see, the buffer solution. Next concept that we are going to see, that is a buffer solution. Okay, because this salt hydrolysis and the buffer solution, they will mix up the questions. So first buffer solution concept if we clear, with the correlation of those two, we will see the questions. Buffer solution. What is the meaning of the buffer solution? Means which resists the change in pH. Which resists the change in pH is called as a buffer solution. In this buffer solution, first one we are having the acidic buffer. So what is the meaning of the acidic buffer? How this acidic buffer is formed? Acidic buffer is formed by the weak acid plus salt of weak acid plus strong base. Okay, how the acidic buffer will be formed? Acidic buffer will be formed by the weak acid plus salt of weak acid plus strong base. Clear? Now this is a solution. Weak acid acidic buffer is a solution of a mixture. Weak acid plus salt of weak acid plus strong base. Examples are, example, if you take the acetic acid is a weak acid, and a sodium acetate. Now you can see this is a salt of weak acid plus strong base, right? Now this is weak acid and this is a salt of weak acid plus strong base, or else you can say it as a weak acid plus conjugate base salt. You can say it as it's a conjugate base salt also. And the second example you can take it as CH3COOH plus CH3COOK. This is also one example. The next example you can see HCN plus NaCN. This is also one example, right? Now next example you can take benzoic acid. all the organic acids are the weak acids. Now benzoic acid said plus CH3. Now benzoic acid plus and the C double bond O Na. Now sodium salt of benzoic acid. Next, clear? Now these are the some examples are also there. These are the some examples you have to remember. Now we'll see how the acidic buffer when it is forming, what is its resultant pH? How to calculate the acidic buffer pH? First of all, we are going to take how the acidic buffer will be formed. First, acetic acid. This is the acid. For this acid, if you add when it has been dissociated, it will be converted into the acetate ion and it will be the H plus, right? Now here for this acetic acid, we are going to add the one salt of its conjugate base. Salt of its conjugate acid, this is a sodium acetate, strong electrolyte. It will be converted into the sodium acetate and the Na plus. Now we know, right, that common ion concept when I have explained, then it is clear, right? If we have taken the C concentration, now it will be converted into the C alpha. Let's suppose this is a 100 molar concentration. Here 0.01 molar and 0.01 molar will be formed. If you take this 100 molar, it will be initially 0, 0. Then it will become 0 and it will become 100 molar and it will become 100 molar. Means this is the acetate ion, it has came from the salt. This is the acetate ion came from the acid, right? Now in comparison with the acid acetate ion concentration, salt acetate ion concentration is high. So we can neglect the acid acetate ion concentration, right? Is it clear? We can neglect the acid acetate ion concentration. Means for the same solution, two common ions should not have the different concentration. Only one concentration it should be have. So that one concentration acetate ion, whose acetate ion concentration is high in the solution, salt one or acid one? Salt one it is having high. So then in the solution what we are having? Salt acetate ion concentration we are having, Na plus we are having, H plus we are having, and the acetic acid we are having. Acetic acid how much we are having? 99.9 molar we are having. So what it will happen? Then the pH will be equilibrium will shift to backward direction, right? Because product side acetate ion concentration has become high. Then if you want to calculate the pH for this one, write the acid dissociation constant Ka is equal to concentration of acetate ion of its salt, because salt acetate ion concentration is high, right? So salt I am writing, by H plus ion concentration by acetic acid concentration. Then Now you need the pH means you need the H plus ion concentration. You need the H plus ion concentration, right? How to get the H plus ion concentration? H plus ion concentration is equal to Ka into concentration of acetic acid by concentration of acetate ion of the salt, right? Then if you apply the minus log on both sides, then it will become the pH. Minus log of H plus ion concentration is pH, minus log of Ka minus log of acetate ion concentration, acetic acid concentration by acetate ion concentration of the salt, right? Then we can say the resultant pH will be equal to minus log of Ka will be the pKa, and this one will be, if I interchange then it will become the plus log, this is salt acetate ion concentration of its normality by acid concentration of its normality. I hope it is clear. This is a pH formula of the buffer. Is it clear? Is it clear? Right. Next one, basic buffer. Next one we are having the basic buffer. Now basic buffer means, what is a basic buffer? Solution mixture of weak base plus salt of weak base plus strong acid. Example, ammonium hydroxide plus ammonium chloride, right? Next one, ammonium hydroxide plus ammonium nitrate, right? Next, if you take the aniline is also a organic acids and the organic bases are the weak, plus diazonium chloride. Clear? Now these are the buffers. These are the basic buffer. Now basic buffer pH. How to calculate the basic buffer pH? Same thing again. Ammonium hydroxide is a weak base. It will be converted into the ammonium ion plus OH minus ion. In this, if you add the common ion to this one, that is a salt of its conjugate acid NH4 plus and the Cl minus. Now salt common ion concentration is more than the acid, right? So this one will be neglected. Then base, right? Because here we are having the BOH. Kb will be equal to concentration of NH4 plus ion of the salt and OH minus ion concentration by ammonium hydroxide. Then the OH minus ion concentration, you will get it as Kb into concentration of NH4OH by concentration of NH4 ammonium ion of its salt. Then if you take the minus log on both sides, then it will get the POH. POH will be equal to pKb plus log salt concentration by base concentration of its normality. Then this is a POH you got, but is asking the pH, right? How to get the pH? pH will be equal to 14 minus POH. In this manner you will get the basic buffer formula. This is a basic buffer formula. Okay, one is a acidic buffer formula, one is a basic buffer formula, right? Now based on this one, now we'll do the question. Now when to use the buffer formula, when to use the salt hydrolysis formula, now we'll see. Okay, now we'll wait. I will give you one question. Now you have to say me. First I will explain one question. So after that I will give you the other questions. You just solve it. Okay. Yes. Any doubt? No doubt na? Any doubts? Nothing, sir. Okay, ఒక్క నిమిషం. Let me check the questions. By 9:30 I will close, okay na? By the 9:30 how many questions we may do, that many we will do, and the remaining we'll do tomorrow. Okay, we'll start tomorrow. Today we'll do up to how many questions we may do, that many we can do, and the remaining we can start tomorrow. Okay. Right, we got the questions. Now we'll see. The question he has given, that it is first, he has given calculate the pH of following mixture. For this following mixtures, pKa equal to pKb equal to 4.74 they have given. pKa equal to pKb, that will be equal to 4.7. Then what he has given, first one, 50 ml of 0.1 molar NaOH plus 50 ml of 0.1 molar acetic acid. What is its pH? Okay, what is its pH? Then when this type of the questions they have given, what we have to do, whether the given question it is a salt hydrolysis formula we have to use, or basic buffer formula, acidic buffer formula or basic buffer formula we have to use. For that one, what we have to do, first we have to do the reaction. NaOH plus acetic acid, what it will give? It will give you the sodium salt of acetate ion. Clear? Now this is a acetate, sodium acetate it has given, and it will give you the H2O. Okay. Now here 50 ml of 0.1 normal means it is a 5 millimoles. Right? Acetate ion concentration is also 5 millimoles. Now you can see for 1 mole of NaOH required 1 mole of acetic acid. For 5 required 5. So there is no LR. No LR means no reactants. No reactants means 5 millimoles of only salt is there in the solution. In the solution we are having only salt. Nothing we are having. Base it is completed. Acetic acid is also completed. Only salt it is there. So the resultant solution pH will be calculated on the basis of only salt concentration. Clear? Now salt concentration, right? Then here, then the resultant pH formula we have to use it as salt hydrolysis formula. Molar mass, millimoles, not mole mass. It is millimoles. Actually ml they have taken, right? Molarity is equal to number of moles into V in ml, right? Molarity they have given 0.1 into 50. If you get moles, you will get. Actually liter if you multiply, you will get the moles, but ml we are multiplying, right? So we are saying it as a millimoles. That's it. Now next, now the pH will be equal to 7 plus half pKa plus log C. Now you say me the pH. Now you say me the pH for this one. The one who is in the live, just say me the pH for this one. Concentrations you can see. 50 ml, this one you have given. pKb they have given. Now say me the pH for the given solution. What is the pH for the given solution? What is the pH for the given solution? pH for the given solution is not the 6, Nana. What is the pH for the given solution? Because there is no any what we can say, there is no any Salt concentration only you have to take. In the solution only salt is there, right? So you have to take it as a 5 millimoles concentration only. But while taking the concentrations, you have to be very careful. While taking the concentrations, you have to be very careful. In the solution, we are having only salt, so you have to take the salt concentration only. Eight. No. Now see here. pH is equal to 7 plus half pKa they have given 4.74 plus log concentration. This is millimoles. This is millimoles and this is concentration. Concentration is nothing but molarity. Molarity is nothing but N by V. N by V means this is millimoles. Millimoles you have to make it into the moles. Millimoles either you have to make it into the which one? Molar. You have to convert this into the molar, right? So 5 millimoles will be 50 millimoles, right? Now 5 millimoles will be equal to the 5 into 10 to the power minus 2. 5 into 10 to the power minus 2 molar. Millimoles you have to convert into the moles. Okay? Because this is a concentration. Concentration should be in the moles, not the millimoles. So 5 into 10 to the power minus 2. Then the pH will be equal to 7 plus half 4.74 minus 2. How much it will become? This will become minus 2 minus log 5. Minus log 5. How much you will get? Log 5 is 0.7 minus 2 minus 0.7 2.7. 2.7 means it will become 2.04. 2.04. 2.04 by 2 it will become 1.02. 1.02. So 7 plus 1.02 will give you approximate. Yes. Approximate you will get. No, already 50 ml they have given, Anana. 50 ml they have given, right? Moles will be equal to 0.1 into 50 by 1000, na? 50 by 1000. 1 cancel. Here 5 and here it will be the 2 0. So 0.1 by 20. 0.1 by 20 you will get. Sir, but plus log 5 will come now. Plus log 5. Yeah. How come plus log 5? Log 5 into 10 to the power minus 2. Na? How much you will get? This will be the 0.05 only. Na? Just do the calculator. How much we are getting? 5 millimoles will be converted into the moles. 0.1 into 50 by 1000. 50 by 1000, huh? 0.1 into 50 by 1000, it will give 0.05 only. Yes, 0.05. 0.05 you are getting, or total volume. Oh, we have to divide it by the total volume of the solution. Sorry. Total volume of the solution. Sorry, sir. Total volume of the solution is 100 hundreds. Total volume of the solution is 100. So it will become 5 into 10 to the power minus 2. Na? Log 10 to the power minus 2 will be log 0.05 will be 1 minus 3 plus 4.74. It will become 3.6. 3.16 by 2. It will become 0.05. So approx you are getting 8 only. Approx you are getting 8 only, right? Right. Okay, fine. Now next one. Next question. Next question he has given 50 ml of 0.1 molar NaOH plus 50 ml of 0.05 molar acetic acid. Now what is the pH of the solution? What is the pH? Now say me the answer. What is the pH? What is the pH? What is the pH? What is the resultant pH? What is the pH? Are you solving or not? Are you solving it or not? Okay, then do. LR if it is present means then you cross check. pH I'm asking. pH. I think 8 only. How come? Now you see. Here, first one NaOH plus acetic acid. Na? Listen. For this one, again it will give you the sodium acetate. Okay. This one, how much they have given? 50 into 0.1, you will get it as a 5 millimoles. Now this one you will get it as a 50 into 0.05 millimoles, means 2.5, right? Then here then acid you got it as a 2.5, then base it will be left as a 2.5, right? Base it will be left as a 2.5. If the base, if it is left as a 2.5, now acid it has completely converted. Now this is the LR. Now it will form the 2.5. It will form the 2.5. Right? Now the resultant solution you are having the basic and the salt. Basic and the salt you are having. But here the leftover solution we are having the basic, right? Now the leftover solution, resultant solution is a basic. Then we have to calculate on the basis of pOH. pOH is equal to minus log of OH minus ion concentration of its normality. Okay, you have to calculate on the basis of pOH. pOH is equal to minus log of OH minus ion concentration. How much we are having? 2.5. That is concentration, molarity. But we need the concentration, right? You have to divide it by its volume, 100. So it will become 2.5 into, it will become 2.5 into 10 to the power minus 2. Then it will become, the pOH will become how much? Approximately you will get it as 1.6. pH 1.6 you will get. Sir, pH you will get approx 12.3. 12.7 I will get approx. Okay. You should not use salt hydrolysis. Here you can see you are having the base concentration same and salt concentration same, but the solution is basic, right? So you have to calculate on the basis of pOH. Okay. Next question. If the concentrations are same, then the resultant solution will be concentrated on the basis of basic. Next one, C. 50 ml of 0.05 molar NaOH plus 50 ml of 0.1 molar acetic acid. Now resultant solution pH. Resultant solution pH. Now you say me the resultant solution pH. What is the resultant solution pH? What is the resultant solution pH? How much you got? 1.6. How come 1.6? Three point three. Atla kaadu. No, that is not the answer. Now you see here 50 ml of 0.01 molar NaOH, right? NaOH plus acetic acid. It leads to give which one? Sodium acetate, right? CH3COO-Na. CH3COO-Na, right? CH3COO-Na it will give. Now this will give you the how much? 2.5. 2.5. Now this one will give you the 5. Now 1 is giving 1. 2.5 required 2. Means this is a LR. LR means this one will be completely converted into the products. Now 2.5 will be formed. Now what it is there? 2.5 of acetic acid is there and 2.5 of salt of sodium acetate is there. Means this will form the buffer, right? This will form the buffer. Clear? This will form the buffer. You can see weak acid is there. Salt of its conjugate base it is there. Salt of the conjugate base is there. Right? Now this will form the buffer. Then we have to use the buffer formula. Buffer formula will be pH will be equal to pKb plus log salt concentration by acid concentration. Now pH will be equal to 4.7. Now log and acid concentrations are same. 2.5 2.5. 2.5 will become log 1. Log 1 will be the 0. pH will be equal to 4.7. Simple. pH will be equal to 4.7. Got it? Because here that's the reason I said you when to use. So when to use the buffer formula, when to use the salt hydrolysis formula. You have to react first of all. Based on that one, first of all you have to react. After reacting you have to cross check the LR. After cross checking the LR, now leftover acid and leftover salt both will form the buffer. Both will form the buffer. Okay, in that manner you have to cross check and you have to solve. Okay, got it? Now next one. Now you say me this answer. Now I will give you one question. Now if you solve this one, you will, whatever may be the doubts you are having, that it will be clear for you. Next, the next question. 50 ml of 0.1 ammonium hydroxide plus 50 ml of 0.05 molar HCl. Okay, now resultant pOH, resultant solution pOH. I am not asking pH, I am asking pOH. Yes, same. So you have to use the basic buffer formula. You have to use the basic buffer formula. Same it will form, but basic buffer formula you have to use. From that you have to good. You got it right. I hope you have cleared with the concepts. Next one, last question I will give you and I will end. Now 50 ml of 0.05 molar ammonium hydroxide plus 50 ml of 0.05 molar 50 ml of 0.05 molar HCl. Now say me the answer. $50 ml of 0.05 molar NaOH, 50 ml of 0.05 molar HCl. Which formula we have to use? You say me, then the resultant pH you will get easily. Good. Salt hydrolysis formula you have to use because okay, you say. Calculate it and say. No LR means salt hydrolysis you have to use. Salt hydrolysis you have to use. pH? No. Why you are using a pOH? pH only you can use directly. pH is equal to pKb plus pH is equal to 7 minus half pkb plus log C kada. Clear? Now its concentration will be how much? 50 into 0.005. 50 into 0.05 will give you 2.5. Okay, 2.5 by 100 because you need the concentration. So it will give you the 7 minus half pkb is 4.74 plus log 0.25. Log 0.25 will be the how much? Log 0.025 will give you minus 1.602. 4.74 will give you 4.74 minus 1.602 will give you 3.13 by 2. It will give you 1.56. It will give you 1.7 minus 1.56. 7 minus 1.56. 7 minus 1.56 will give you the 5.43 will be the pH. 5.43 will be the pH. I hope it is clear. Clear Aina? Or still you are having any confusion? Clear? Right. Okay. Now by this I will end the lecture up to here, and tomorrow we'll see how the action of buffers, graphs, and salt hydrolysis. Okay. Bye.